Yeah, we could go through it a little bit. The idea that I have for it. I'm just gonna fix some stuff on the stream here. All right. Okay.
What do you think of the new async interface, by the way?
I think it's cool. I haven't used it that much.
Yeah, me
but
neither.
a little bit. But it looks promising. Like,
I think the concept is cool. That like you can write like asynchronous stuff, like completely like what is the word, like indifferent to the like implementation, like whether it's threads or like IO you can just write async and then you can basically specify like a build time or when you build which implementation you can.
yeah, exactly. Yeah, no, I think it's pretty cool. Exactly, like you can even like switch out, you know, implementation if you wanna use a different implementation for a different thing, but still have it like, you know, you don't have to switch the. Yeah, it's like an interface. You don't have to switch out the usage of the async. You can just switch out the implementation if you want to change that.
Yeah.
Okay, so I'm just. Are you watching, or do I have to share or something?
I'm almost back. I'm gonna turn the laptop.
Okay.
So
Let's see. I'll remove the module here. We'll just do the main. Oops. I usually have like. All right. Okay, so we need raylib. Let's see if I remember this. So it's like git plus. I think it's in raylib zig. Yeah. I don't know if zig package, if that's supposed to be in git ignore. Maybe it's not. I don't know, because I saw a library that didn't have
zig
it.
package.
Yeah.
Ooh, I think if you have. No, I think you are supposed to ignore, because if you have the build.zon, then doesn't that like include it, or like doesn't that have the, or it includes all the dependencies?
Yeah, I don't know.
When the user builds,
because I saw a library that didn't
I think
actually ignore
just...
it. So.
Yeah.
But yeah.
Isn't it kind of like node modules?
Yeah,
like
exactly.
Just, you're not supposed to actually...
but it usually it used like zig cache. I'm not sure if it has changed that to use zig package instead, or if it uses both. I actually don't know, but there's also a thing where if you have like a version, because Node uses a thing called a lock file, because some dependencies you can install their dependencies using like a version match that could potentially change the version if you're if they have like a loosely defined version match on those dependencies, and that could lead to things not working because you install a different version than was tested originally. And so but I think Zig probably has, I think Zig has like strict versions, so I'm not sure if that's even a problem for Zig. So I don't know. Anyway, so are you? Can you see here, or have you?
What do you mean?
No.
Hang on. Almost. I'm gonna join from my laptop.
Yeah.
30 seconds.
Let's see. So now we have raylib.
Yeah, and also I've never used the like collaborative Git command.
Oh yeah, I forgot to add it. Sorry, what did you say?
I've never used the collaborative Git commands, so I'm a bit of a Git. I only know Git add and Git commit and Git push and pull.
Could you repeat that? Sorry, you don't know Git?
I don't know the Git's like the collaborative command.
Okay. Well, I mean, you just need like Git, Git add, Git add, Git commit, Git push.
If we change the same file,
yeah,
then
if I pushed something that changed file A, and you then has like a previous version and you change that file as well and push that. If I push first, when you push, you're gonna get rejected because you don't have the latest version.
So I need to pull it first.
So you need to pull, or if that doesn't work, you have to merge. So you do like git merge.
And if you merge, then it gives you like the kind of CLI, and you can see which.
Well, it doesn't actually do that. It kind of edits the file.
Well, there's something called patch or something.
Yeah, but what you usually do is you do git merge, and then the files that have conflicts in them. So first it tries to auto merge. If that doesn't work, so sometimes you don't have to actually do anything. It just merges and it just works. But sometimes you get conflicts, and that is if we change the same file in the same place at the same time. And if that happens, then it edits the file. So then it looks something like this. So, well, I don't know if you can see my screen now, but it inserts like both versions in the same file. So you have to go in and kind of manually edit it. Or there are tools like, if you're using NeoVim, for example, there's like tools for like choosing which version you want and stuff like that. But you can also just manually edit it as well. It's not really that complicated.
Okay, I'm watching the stream.
Okay, cool. But I mean, if we run into that issue, we could take it then. So we don't really need to worry about that right now. Whoops.
Yeah.
So we have raylib dep, raylib. I think this is the only thing we need to do here. Then we have module. I never remember if you actually need to like link an artifact bindings? Or something. Sorry?
Are you using do you use the raylib-zig bindings?
Yeah. Oh yeah, this is
my microphone okay?
I think it's underscore is how they say it, yes. Okay. Yeah, and then we have to add it as an import. And I'm gonna assume that they don't mind us using zig. Because it said like, yeah, it's a C library, so you have to be you have to know C and all that.
Sorry. So
I think, yeah,
the
it said
the hard constraints just 720 by 720 resolution, must be run on web,
right,
and must be under 64 megabytes.
yeah.
Then the soft constraints are games should use the provided template and should be playable with keyboard, mouse, and touch, and should be open source.
Oh, this is
So-
on the actual Raylib main like GitHub account. The Raylib game template.
Yeah. Did you see it?
I haven't looked at it yet, but
It's basically just, yeah, so it's a bunch of C code. It's basically,
okay.
they want you to just have like a screen, like I guess a logo screen and a title.
Okay, cool. Well, I guess we could look at that later. We don't have to do it for this one. We could do it maybe if we do one more game. We could do it for this one. Okay, so we should have Raylib now. No? What's happening? I added. Oh, sorry. This is not how you do it. You do name Raylib.
Yeah, I think the build system, or Zig's build system, is the most probably the worst part about Zig.
You know what?
Like,
the problem is the documentation. It's so lacking in documentation, so you have to kind of just look at examples. Also, the trouble is they keep updating it, so next version is going to be a little bit different. So, like, this is not how you used to do it, and then they changed that. But yeah, and you have to kind of like get used to it, and like, yeah, just it's like arcane, a little bit arcane.
Yeah, for sure.
Okay, so you got Raylib here now. Okay, cool. So what you do is like just init window. This gives us a window. This is 720. We have a title, Tetris clone. Okay, and then we have while window should close, begin drawing, and end drawing. Okay, so this is our basic window. If we just run this, we're gonna get our window here, or not. We could get a compiler as well. Oh, init is not used. Okay. Okay, I'm gonna make this window appear.
Okay, the stream is a little bit behind, so does the window work?
Are you watching on YouTube or Twitch?
Oh, I'm on YouTube. Is Twitch faster?
Yeah, Twitch is much faster.
Is it still Lumor's?
Yeah.
Email? What does that name mean? Lumor.
It doesn't mean anything.
Is it like a Swedish thing?
Well,
Lumors.
sorta. It doesn't mean anything. There's nothing actually named that. It's just a mishmash of different things.
Okay.
But yeah, so yeah, so now we can run this. We get a window. I'm just gonna also set the position of this so it's always in like 0, 0, so I don't have to watch it move all over the place. Okay. All right, so that's our basic thing. Yeah, that was the easy part.
Getting the window is the easy part.
Yeah. So I'm thinking we probably, I mean, let's just start by having like, I don't know, some kind of game struct. So let's just have this like contain all the data. And what I'm thinking is we need some kind of grid, because the grid is like the current state of the game, or the current, like all the blocks in the view.
That would be like a so that's like a 2D array.
Well, it doesn't have to be a 2D array, but it's probably, well, we'll see. It could be also a 1D array, that because it's easier to like initialize a 1D array. But it doesn't have to be. It could be a 2D array as well.
So okay.
I'm gonna.
But how? Yeah. So can we just go over it like conceptually? Because I don't. Like, I don't know. Maybe we should.
I'm googling here. This Tetris classic grid size, because I was looking for. Okay, so maybe I should bring up GIMP or something here. So
bring up get or like maybe like Google Docs or something, because then I can write there as well or something.
Yeah, I mean, I'm just gonna draw a diagram so you can try to. I could do that later, but essentially what I'm thinking is something like this. You have like, you know. Okay, maybe I should do like this. I don't know. A bit simplified here.
It's fine.
Okay, so this is like the game board or map or whatever.
Yep.
And so each cell is, you know, it's either, if the most simplest way to do it is that each cell either is like solid or not solid. So it's like all of these are 0, so they are like not solid, and so on.
Yeah.
But then maybe you have like dropped a piece here, so maybe it's like something like this, right? And so when we spawn a new piece, I don't think we need to modify the grid at that point. We just, that's gonna be a separate thing, I think, would make sense. That has like a position and maybe rotation, because you can rotate it. And then every time it like drops down or you move it or something, it's gonna check like, are we colliding? Like if we have a piece like this and it's moving down, we're gonna check like, does this collide with here? In that case, we have, this is gonna now, all these are gonna be ones. That's what I'm thinking here. And then if you drop something down here, so you get a line, then we have to basically everything from above needs to move down one.
You can go by column, and you can check. like, is it like 1, 1, 1? Like, is there a space? Like, is there a 0? Like, if the block height is like 3, then it's like 1, 1, 1, 0, 0, and then whatever blocks are beneath it, 1, 1, 1. So if there's zeros in between, that means it's not colliding. And if it's colliding, it's just like a long string of ones, and then that's when you know that's where the motion stops.
Yeah, I think what you could do is you could say during a step, I'm gonna call this a fall step.
Yeah.
So first, the piece is gonna move down. Piece moves down, but it's not the final position of the piece. But the position is gonna be modified to go down. It's kind of like the velocity is like it goes down. So we apply the velocity going down. It just means it moves down one step. Then we kind of sum up. We could sum up like the grid with this piece in place. So we can, if this piece, then this piece gets added in. So it gets added in. We need a way to kind of translate the piece like onto the grid as zeros and ones, like this. Let's say this is like the piece kind of box.
I don't think there should be any like. Wait. Okay.
No,
okay.
no, just let me finish here. So, so I can finish my explanation here, and see if you agree or not.
Yeah.
So we basically add this into the grid, and then this gets a 2, right? So then we can check. Okay, are there any 2s in there? And if there are, then that means we have a collision.
Where does the 2 come from? So we just
because there was a 1 here before, and we add in this new piece, which is like this here. And so this is added onto here, which makes this a 2, because it's 1 plus 1.
Right, okay.
Yeah, so then we know that there's a collision. I don't know if this is like I mean, it's one solution, so, and Tetris isn't really that, needs optimization or anything like that. So, but then this gets a, now we know that there's a collision. So what we do is we reverse, I'm not going to write this down, but we reverse the movement. So it goes up. So it basically, now it's up here, because we know that if we it didn't collide before, because we have checked that the step before, and now it did collide. So now we move it up, back up, and then it's gonna get stuck there.
Yep.
Yeah.
Yep.
And then we just add it here instead. So we use the same operation, just in a different position. So that operation gives us both the collision and also actually modifying the grid. And then for like game over, we could just say that, okay, well, if you have I guess if you have like a 1 at the top row or something, then it's game over or something like that.
Yeah.
All right.
Right. So okay.
Yeah.
No, I'm just thinking about it. Yeah, okay. So then you don't have to store. Yeah, that makes sense.
Yeah, so the piece will kind of be its own little grid, I guess. I mean, what we could do is we could store each piece and all the rotations in a table, and just use that as a grid. The position could be like the top left. So the entire piece object could be like a rectangle like this, or a square or whatever. And the position could be over here. And so then we could see where you can have. The one I'm thinking is like if it moves to the right or
right,
to the left.
and then when we rotate it, the pivot can be like the middle block of the square or whatever.
Yes, exactly. That depends on how we define the data, I guess. So I mean, yeah, if this is like this and the pivot is over here, yeah, exactly. Then that should work.
But how would you do? Yeah. Let me check out. But how do you do like the really long block? Like there's a really long skinny block.
Yeah, that one is actually a little bit.
Like how do you rotate? Like where should you rotate?
Yeah, that one you have to kind of decide where you rotate because there's like two options, right? Because there is like the top or the bottom, and also I think that if you rotate it one way and then back again, it's the important thing is that it has to have this. It goes back to the same position. So if you have this, if you have a long here, but then you rotate it like this or something, it's either gonna be there or up here.
Yeah.
I think down here is harder. If you rotate it up here, it's gonna be easier because then it's like further up. I think actually Tetris actually has it up here. Because that's easier, like gameplay wise. You can also decide if it's gonna go to the left or to the right, I guess. Also, it depends also as well. Like if you're actually at the edge here and we rotate, we have to kind of push it over like this, right? Because there's no room over here as well. And same for this one. But the important part, I think, is if it's in the middle here and you rotate it, so it goes like this, and then you rotate back. The important part is that it keeps the original position, I think, because that kind of makes sense when playing, like in your mind, like I wanna undo the rotation I just did. So
I think the rotation is, I don't know. That's the only thing I don't really have a model of yet, but.
No, I think we don't really need to like calculate anything. We could just have each rotation in a table.
Like hard coded?
Yeah. That's the easiest way. And then if it's like here and you rotate, this gonna try to be like this. We have to have some way of checking like, is it outside of the grid? And if it is, we're gonna have to adjust it, like move it.
Yeah, that's true.
Yeah. Also, the same thing applies when we are next to a thing here. If you rotate here, it's gonna end up like this. Or well, it doesn't actually fit here, so you can't rotate, I guess. But yeah, that's also one thing we have to account for. If it doesn't fit and you try to rotate, it doesn't actually rotate or something like that. Yeah.
No, so I think there is like a single kind of pivot point, because I'm just playing Tetris right now in the browser, and it always does seem to kind of rotate around the middle. But if you are touching the edge, then I think that pivot kind of stays the same. So then it kind of just moves it.
Yeah, but does it rotate it? I mean, since it's 4 blocks, there's no middle block to pivot around. You have to choose if it's gonna be the top middle or bottom middle block.
Okay, let me just see. I'm just playing Tetris. I think. I don't know what it is. I think it's. I'm just gonna ask Claude. How to?
The hell is this?
Okay, so how do you think you would like organize? Oh, you're also playing it.
Yeah, but
how do you think you would?
Oh my god. This one, I actually remember this one. This is like an old school. Okay. see if I can get a long. Okay. Yeah, so you can see it pivots on the left one. And when it goes back, it pivots on the upper one. Did you see that?
Yeah.
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 So left and upper, I think. Yeah. I think. Yeah, exactly. So.
Or that could just, yeah.
Now I'm just playing Tetris. Okay. But and if we're on the side here, it gets pushed.
So basically, yeah.
No, I couldn't actually rotate it, but that's an implementation detail, though.
You need to reject. Yeah, so you can either choose to reject the rotation and then push the block in the other way.
This one you can't actually. You can't rotate.
That's the simpler way to do it. It's just not allow the rotation, which makes sense.
We could start there. We could start with a more simple solution and maybe get something else if we have time. Okay, well, anyway. Cool. So let's just make this grid here, because I think that we probably need. I mean, if you want, I could push this up and you can start working on the input if you want. But you don't have to like hook it up to actually like doing anything with the data yet. Just, you know, doing the function that handles input, like you know, if raylib dot is key down or something like that.
So like just like keep saving it as like an enum, like the input event. Like
well, either that or we just modify the data directly in the input.
Yeah.
Maybe it depends. Like if we want to have multiple functions for the key press, if we're gonna have like a menu, or I don't know. Or if you're gonna be, let's say maybe you can hold it down and it's gonna step faster or something.
Yeah, that's true.
Yeah, just do something there. Start with an enum maybe. Do what you thought there. I'm just gonna. Okay, so I'm gonna push this here. Don't really have a. I don't have a set it up for a project yet, but I'm gonna initialize one here. 1 second. Repositories. All right, Tetris clone. All right, we have the thing up now.
I see it.
Let's see if I can add you somehow. I'm not sure how you do that.
Me neither.
Collaborators.
Honestly, I just realized.
Yeah.
I don't think like. I mean, maybe this is a bad idea. But I don't think I'm like capable of like. I don't know. I don't think I'm capable of like coding in the same like project, like I don't know. I feel like it just has too much overhead of like communicating. So I feel like, what if we both just worked on like Tetris clones at the same time, and then we can just compare at the end. Like we can just communicate with each other if we have questions, and we can say like.
Oh, okay, you think like that. I mean, I think it could
Because
be.
I realize I feel like this is gonna go like. I feel like I might hold you back from your style, and you know what I mean. Like I feel like if we could actually both have like two separate working Tetris clones, and we could just show it off and compare.
Yeah, but what I'm thinking is like it's gonna be also like practice for actually collaborating on the same project, because that is
I know,
very
but I feel
different.
like, yeah, I know. Maybe you're right, but I feel like just for this, because I feel like already, like like I
You
feel like
struggle
that
seeing
looks,
my idea or
yeah,
my yeah. I
yeah,
think I
kind
see.
of.
Yeah.
And I feel like collaboration works best when one guy is doing like like maybe one guy is doing like, yeah, like a well, like you said before, like
Parallelization.
parallelizable, yeah, like a, yeah, like an asynchronous, like two people are working like concurrently on like.
Yeah, I mean, usually, I mean, this all is depending on the task and all that, how you actually collaborate with someone. But it's like the thing is like if before you start actually working on task, usually the programmers or developers will, ask questions so that they really understand, what they're supposed to do. But usually in this setting, also you have like a product owner that actually decides what is supposed to happen, like what is supposed to be implemented and stuff like that. We don't really have that. We only have like you and me, and we come up with a solution together. And I mean, I could just ask you, like, how would you start to think about this, or or are you more like you would just want to get to start coding and see, like, going like one step at a time? Well, like, where would you begin with this project, do you think? Also, what is your username on GitHub?
On GitHub, um, it's Tristan Jet.
It's Tristan. Okay, yeah. I just added you there. Yeah. So how would you start on this project, do you think?
I would start. Well, I think the collision that you explained makes a lot of sense. Yeah, but I just
Yeah.
feel like the iteration speed is a lot faster if you're kind of like working independently on something. Like, because I feel like, or with this Tetris thing, we don't know, or like unless you can explain to me like the boundaries of like, okay, like something that I could work on like independently, and then explain to me what you're working on. You know what I mean? Because I don't really see like the lines, or like where the abstractions are and where they end.
Okay. Well, I mean, yeah, that is one of the harder things actually to come up with. If you have because this isn't really a very large project, so it's like there's not many areas that could be parallelized either. And once you've done like one thing, it goes by pretty quickly, I would probably say. So it's probably not a good project for parallelization.
Yeah.
So that's one thing. But that's what I'm thinking. Like input is one of the things that could be like it does depend on like other things, but also at the same time it could be its own thing if you do it like you're thinking there, like an enum. I was thinking more like, because my idea was like implementing it halfway down basically. So you do all the key buttons, mappings and all that, and you have like ifs and whatever for like if this is key this down and have just, instead of having the actual implementation, you have a comment or something that says like, do this when this key is down or something like that. And then you have like a ready kind of template that we could then just, you know, fill in the rest, fill in the blanks when it's ready. So that's one way to kind of parallelize the work. But also I think it's like when you also communicate with someone else with like on how to solve a thing. I mean, it depends also on the program. Like some programmers like only want to solve the problems themselves, and you know, I've been working with some of those as well, like that work more independently. I've been working more also with people who, you know, enjoy, you know, working together and try to solve things together and discuss different solutions, and you know, being on page with, you know, what solution you pick and stuff like that. And also then, even then, you could also like, you come up with a solution together, but then you also parallelize the work, so you can begin working on different areas at the same time as well. But and I was thinking that if we get like the data, like the main like kind of like API of the game in place, then you could just basically just use that to, you know, it's probably not going to be a lot of seeing what happens. Well, it could be that. It could be like, you know, because I'm also used to doing that as well, like implementing something, seeing how far we went. Like, did we get a block in rendered, or did we get a piece in that's rendering? Do we see anything on screen? What is happening on screen? Do something else. Iterate what is happening now on screen. You know, some programming like that in contrast to like making the plan, implementing it piece by piece, where we don't see the end result until everything is tied together and everything works perfectly. That's basically never works that way though. You usually just, yeah, you have to iterate and see the thing over time growing into a working product. So, but yeah, I don't know. Anyway, I don't know. It's up to you. Do you want to do it separately, or do you want to try collaborating more? I mean, it's kind of like a smaller project, so maybe we could sort by separating this project, and maybe we'll do another one that's slightly larger for the next one, and then we can see if we can collaborate more on that one. What do you think? Are you still there? Oh. Okay, your mic died. Okay. All right. Yeah. Sure. Okay, separate, right. So, okay, I guess I'll just continue here, and you can continue on your own, and we'll catch up when we're both done, I guess. All right. Yeah. Cool. All right, I'll hang up here. Okay, let's just continue then. So, yeah, so I was thinking like a game struct that has like all the data. So I want a grid. Actually, let's make a grid struct. And let's have the data is going to be a slice of I think a cell. This is going to be something. So this I think I'm gonna do like some kind of union here, where it's empty, or it's okay. Let's just do empty or solid for now, and we'll see if we can do something else. It doesn't need to be a union enum for now, but I'm thinking later I want to have some stuff like colors and stuff. Actually, let's just do an enum for now, and we can always change it later. It's pretty easy to refactor that. So that's basically a slice of cells, mutable, okay? And that is what we'll have there. I think we have like an init, and we're gonna have like width, or let's make a size. No, let's just make width and height. Okay. Whoops. What the hell was that? I don't know what that was. Oh, UUID. What is that? Snippet? I don't know. Okay, so this will be like data equals, and then we also, yeah, we need an allocator as well. Memory allocator. For some reason, the LSP stopped working. Data is also, this can be an allocator error now, so this can be allocator, allocate width times height. And what are we allocating? We are allocating cells. Okay. Also, we are trying this. Cool. So that is that. Now, actually, you know what? This doesn't work because actually, you know what this will be? This will actually be a struct with a value starting at 0. So the value is like, yeah, that's how we add. That's the value. So now we can add two grids together and get their value to see if they collide or not. That's the idea. And then we can add other stuff. We can add like color if you want to have this rendered in a different color or something like that. But let's start with a value that's just 0 there. Yes, so we have a grid. Now I'm thinking we want this operation like adding. Actually, let's add this. Let's add a color right now, actually. And actually, let's start with black, because that's the store. That's like when it's empty, it should be black, right? So now we can actually do. We want a grid here. This is the main grid, and let's do an init here as well. We need an allocator. What's happening? I'm not sure what's going on with the formatting there, but and then we return grid equals try init allocator, and then I guess we'll have like board width is, well, yeah, and this was, I was googling this here, the thing. Where was the thing? Did I remove that? Okay, Tetris, classic Tetris board size. 10 by 20, so 10x20 y. So width should be 10 and height should be 20. And now I'm thinking here is that I'm going to actually like add walls as well. Probably, maybe. We'll see. We'll see what happens here. But there's gonna be something for the walls so that we get like the rotation. Like you can't move against the wall and you can't rotate into the wall. So, but there's gonna be a difference though. Is like when you get a Tetris, those walls are not gonna like disappear. Or they could, I guess. When you, yeah, I guess they could also disappear, I guess. But then when you move everything down, the top layer would include walls as well, I guess. So board width should actually be like +2. I'm gonna do. Okay, so there we go. Now we have that. I'm gonna say we have a game here. We init this with an allocator. Oops. The allocator is going to be init GPA. No, it's gonna be the arena. Let's do GPA. And I will do like a dinit. I guess we can store the allocator here. Man, why is the indentation weird? The initialize self is a game. Self grid. The initialize. Free self data. Oh. Okay, now it seems to be fixed. Okay. We could also make like an arena for things that's only gonna be initialized once. But I don't know. Let's just do everything manually. There's not gonna be that much stuff. Because I'm thinking like an arena is not good for things that get constantly allocated and deallocated. Although we probably won't have that though. I mean, we probably just allocate everything once. There's not gonna be much dynamic stuff happening. Probably nothing actually. Anyway, whatever. Let's just do it like this. Okay. So now we should have a game, and now we can also... I'm gonna add a function here, draw grid. And so this would go through the grid. Actually, we probably want a position as well. And maybe scale or something. But we'll go through 0 to grid. Also, grid needs to store the size. So we need to have width and height. So we know that. Width is width, height is height. Because then we can say here, we can say go to width, this is X. And then we go to height, this is Y. And then we have position, it's going to be position, add X, Y, except these are U size, so we have to like float from int okay. But now we have the position, and then we draw the grid from there. So this is gonna be so we have the cell, it's gonna be grid data. I guess we could have a function for this, get cell X and Y. X and Y. This gives us a cell. We could also make it return the like a pointer to the cell if we want. This could be called get cell const, and we'll make a variation if you don't need it to be, because now we can make a convenience function here. It's like it's gonna be like index xy. So what this is doing is it's turning a 2D, coordinate into a 1D index. And how you do that is you take x mod. Actually, we need width here as well. So modded by the width. So x will never like be larger than the width. It will like be from 0 up to width -1, and then we add y times the width, which it corresponds to each row. So the first row, this is going to be 0 because y is 0. The second row, this corresponds to the width. So if width is 10, then this is going to be 10. So essentially x0, y0 will be 0. X0, Y0, this is going to be 0, index 0. X1, this is going to be index 1. X2 is going to be index 2. X3 is going to be index 3, and so on. Until we get to index, well, 9 is still 9. And then this goes now to, well, x shouldn't be larger than width anyway. Actually, we don't need to mod here. We just take x. I just realized the modding is if we want to do it the other way. Yeah, anyway, x is 0, but y is 1 now. So this corresponds to 10. So this is how you can see like how we can map a 2D coordinate into a 1D array index. So the first row maps onto the first 10 cells, and then the second row maps to the next 10 cells, and so on and so forth. So yeah, that's how that works. And you can also turn it the other way around if you want an index to be turned into a 2D coordinate, but we don't need to do that right now. Okay, so this does gives us that. I want a version that gives us the pointer. So now we need a mutable grid, and we gets a mutable cell. There we go. Now, yeah, draw grid. So we get the cell. We don't need to mutate it, so we can get the const version. So now we have the cell, and now we say, okay, well, let's draw a rectangle, and we can use like a rectangle like this. You could use like V, where you can provide position and size. This is probably the easiest one we can use right now, I think. So the position will be P, and size will be cell size, which we don't have yet, but the color we have color there. Now the cell size is actually something we can decide here, like a global. So this could be a vector 2, and maybe it's like 16 by 16 or something. I don't know. It's just something we decide on, which means that P actually also needs to, because this is grid coordinate, it needs to be transferred into a pixel coordinate. So now it's grid. So what we do is you multiply by the cell size to get the pixel coordinates. So cell 1, 1 will translate into pixel 16, 16. Cell 2, 2 will translate to pixel 32, 32. Okay. Okay, so now we have a thing for drawing the grid. So now we can actually get something on the screen, and we can draw the grid. And the grid we want to draw is the game.grid. And the position, I'm just gonna do 0. Okay, let's see if this gives. I mean, it's just gonna be black. Actually, it's gray. Okay, strange. Why is it gray? Also, it seemed to lag a little bit. Maybe, or maybe that was just a one-time thing. I don't know. Okay. Actually, I want to move you to like, I don't know, 24 by 24, because I don't see the tile, or I mean the header of the window stuff. There we go. So it's up in the corner here. Let's see. What we could do is we could also draw it like in the center if we want, but I'm just gonna draw it up there for now. Why are they gray is the question, because this should be black. That's very strange. Yeah. Oh, maybe it's because it's like garbage data. So it's like OXFF or AA, I mean OXAAAAA. Okay, that makes sense. Okay. Because when you're in debug, when you're like in development mode, Zig sets everything like that is not initialized to something. It sets it to 0xAAAAAA, so that it's easily spotted as something that is not initialized. So I think what's happening is this data is not initialized, so we get the kind of debug value for those. So what we need to do is actually go through all the data. So what you could do here is you could get the data pointer first, and then we can actually go through and I mean, we could just zero it, or we could just yeah, you could do like mem set, I guess, but there's also like mem 0 0 init. You could do, or we could just loop through the data, each cell, and we can initialize each cell. So cell, we need it to be mutable. So cell is equal to the normal initialization. So that gives us the default values here. Okay, and we have to, you know, if you iterate on a slice and you use this star here, this means that you get a mutable version of the, so now you can mutate, you get a pointer to the element in the slice. But if you would do this, you would just get like a constant copy of the element in the slice. So if you want to mutate the slice while iterating like this, you have to do this. All right. Now, if we run this, it should be black, I hope. Yes, so now it's black. And if we, for example, we say that color is red, we should get like a bunch of reds there. Yeah, cool. But that's not what we want. What we want is we want to initialize the walls. I'm going to say, so we want to initialize the wall. So what I'm going to say is I'm going to get the index here. We could either do it here, or I could also do it in a separate function here. That is like init board. The reason why I don't like this is because you probably want to do it here when initializing the data, but whatever. Let's just init the board like this, because now we have self, which actually points to, well, this is not, we should have it in the game, actually. There we go. So we init the board, self is game. So now we actually have a pointer to self, so we can modify the correct pointer to game. And we are going to go through each from 0 to board height, or we can even do self grid height. We get Y here, and still don't know why the formatting, like the indentation, doesn't work here. That's very strange. Anyway, maybe it's thinking it's a different width, like, I don't know. Anyway, so we have this now. So we go through each Y, and what we want to do is we want to say set we could do a thing here where we have like set cell. So we set X and Y to a cell. So self data, we could do self get cell XY equals cell. Okay, so then here we set the cell of X is 0 for the first wall and Y, and then the cell is going to be value is 1 and color is black, because we don't really show the wall, except we could. I mean, we could just make it gray or something. Is it gray or gray? What's happening? Oh, sorry. Gray. Do both work? No. It's gray with A. Okay. So now we can do that. So now we have to also call this function init board, and we'll run this and see how this looks. Okay, we got the first wall here. Great. Oh yeah, I forgot about the floor as well. But yeah, let's also do then set cell, and then this is gonna be the grid width -1. That's the opposite wall. So now we have 2 walls. Great. Okay, let's also do +1 height. And we're gonna go also do the floor here. So this is walls, and this is the floor. And the Y here should be grid height -1, because it's the last one there. Yes. And for the floor, I'm pretty sure well, it's gonna be, yeah, okay, we'll get to that later anyway. So let's see what's happening here. Oh, does that look correct? I don't think so. I think we need to switch out these two. X needs to be the first and Y needs to be the second. Okay, now we have the walls and the floor. Cool. So okay, what I'm thinking now is I'm going to just make a piece, and yeah, so I think we need a struct for the piece, or this is called a tetromino, I think. Tetromino. I think so. It's called a tetromino. Tetromino. Yes. And what I'm gonna do is I'm gonna say it has a grid, and then it has I'm gonna say that this has like a next rotation to point to what tetromino it's gonna become in the next rotation. This is gonna be like a pointer to another tetromino. Now this data could be the tetromino type, actually. I'm gonna say it's a type, or maybe type is a bad name, I don't know. Let's just have it, sure, let's just do that. And then we have the actual tetromino. This is like the instance of the tetromino, which has an actual position. Maybe the position actually should be a, well, let's have it as a vector too for now, because the problem is that this is floating point and we're working with a grid which is integer based. But so I'm thinking you could either have this, you can also have a vector of view size that works very well as well, but I'm just going to use the Raylib vector for now, and we'll see if we can change it later. A position, and it's also going to have a type, but I'm not sure if it can be called type though, because type is a keyword. So I'm going to call this class. Okay, sure, let's call it class. No, class is bad. I'm gonna call this static, because it's like static data. Okay. And then What else? Positions that, okay, let's start there. And now we need a bunch of these, but I'm going to just make, I'm going to make one for now. So we'll have the T tetrominos. We could put it in a namespace like this, and we'll have the T shaped. I think it's called. That one is a, so this will be like T1 for the first rotation. I don't remember if it usually comes down rotated up or down. I'm gonna do up, I think. Yeah. So we'll have a, so this is going to be a tetrominostatic, and it's going to have a grid. Now the grid is interesting because we could probably do something like, let's say we init with a, so we'll have like a parse function, and we'll do like, we could do like dots for empty, and then maybe hash for filled. So this could be something like this, for example. Okay, so that is the, it could also be, we could also make it like larger like this. I think it makes sense to have it. Yeah, let's just do it like that for now. It's not really a square, but it's like 5 by 3. It's just for rotation. We don't really need these extra here. Yeah, so we'll do this. So what I'm thinking is I'm gonna make a compiler comtime function that parses this into a grid, which is like comtime no. Okay, let's hope I can do it, because I'm not sure if it's actually gonna work, but we'll have a parse function that gives us a grid. Okay, and here we have a comtime data, which is a string. Okay, or source, I guess we could call it. And we could go through, so this should all happen in comtime and give us a thing. So either we could mark everything in here as comtime just for safety, I think. Okay, maybe like this. Okay, so we're gonna have, let's just make cells, which is a slice of cells, and we'll start out with an empty. Now, well, actually, we could actually calculate the width and height, I think. So let's say the width starts out as 0. Maybe we will actually just loop through count source, or counting the number of new lines, and that's going to be actually the height, and +1 because because we are counting the last one as well that doesn't have a new line. There we go. Okay, so then the width should be, it's just going to be like index of scalar slices source and values dash. So we're kind of assuming that it's going to be correctly formatted here. but we calculate the width and the height here. And so essentially now we can just actually just return, well, no, let's create the grid here. But we don't actually use an allocator. What we do is we say, well, we don't, okay, let's create the cells actually first. So cells is going to be an array of, or yeah, it's going to be like an array. I wonder how this works. Like, it's an array. This should be like ComTime array, so it should be available, right, in like read-only data. But this is going to be like width times height cell equal to undefined. So this is our array, and then in the end we could return the grid. So we can return cells or data equals cells, width is width, and height is height. Kind of overkill for this little project, but it's fun to do these things. Okay, and so here we're gonna say, yeah, I guess we just loop through width and we could actually yeah, let's just loop through width. I'm gonna do this length is width times height. So this is length, and we're gonna loop through all the lengths. This is the index. So now we can say cells.I equals, and it's gonna correspond to source I, except source I is like either a dot or a hash tag symbol. So if source is dot, then the cell is going to be the cell is actually, let's do like value is a usize. So the value is going to be 0, otherwise it's going to be 1. So it can be actually, it can basically be anything else than a dot. If it's a dot, we could also do, I guess we could also do space. Maybe that's better. I don't know. Maybe dot is good because then you see like the grid. Okay, so anyway, we have the value is 0 if it's a dot, otherwise it's 1. And then we say cells I is equal to value is value, and color, I'm thinking we can also pass in a color here. It doesn't really need to be ComTime. Well, maybe it does. Whatever. Let's make it into a ComTime. Hey Blue, what's up, what's up? Welcome. Let's see. We're making a Tetris clone here. Okay, so I think that should do it. So now we're populating the cells. Each one is gonna be parsed from the source. If it's a dot, it's gonna be a 0. Actually, yeah, if it's a 0, so if value is 0, this is going to be black. Otherwise, we're going to take this color here, right? Because if it's 0, it should be empty. Okay, there we go. I mean, another way you could do it is if in the draw function, if it's 0, we just don't draw it. Like, that's probably more efficient as well, but hey, whatever. Okay, so we have this parse function. Now hopefully this works. I'm not sure exactly if it's going to work. What we're gonna do is we're gonna create our little tetromino. So I'm going to say we have an active tetromino is a tetromino, and I guess it could be null, it could be optional as well, but let's have it not be optional for now. And then we'll set this to, let's see, we could make a convenience function here. Position, and actually, when we create it, we could probably just default the position to, no, we can't default it here though. We have to default it here because it doesn't work. Because it's a C library and it does some weird stuff with the comp time. It doesn't work. Default assigning it actually is a comp time value, so it tries to evaluate in comp time, and then for Raylib vectors, I don't think it works. So we have to do it here, but that's not an issue. So we have init, this gives us a this type. We are now saying position equals to 0 and static is static. What's happening with the formatting? I have no idea. And active tetromino is going to be init. The static is going to be tetrominos.t1. There we go. So now we have an active tetromino. You need a color, so I'm gonna give you purple because I think that's what I'm kind of used to having the T's as. Okay. Oh yeah, so if we didn't find, right, if we didn't find a new line, that means we should just get, that means the width should be the same length as the source. Okay. Missing next rotation, right. So next rotation, it's just gonna be itself. It's gonna be recursively picking itself. Oh, it depends on itself. Okay, that works. Yeah, cool. It's kind of cool that you can do this because the address is like a, yeah, I don't know. It's a lazy address or whatever. Anyway, it's Blue says it's hard for me to decide when to use an allocator. Yeah, I think it just comes with experience. Like I have also trouble with deciding what allocator to use and when should I just put it on the stack. You know. It's just a thing that, I mean, I'm constantly experimenting with different ways of doing things, which I just think is fun when it comes to programming, that you can do things in such a lot of different ways. And Zig is especially is a language that allows you to do things in a variety of ways. So I'm having tons of fun with this, especially with like the comp time stuff here. So this is pretty cool because now we have this parse function. We can just put a string here. It will actually parse this in comp time and give us a runtime like static or like a, you know, a comp time on value for this thing here. So anyway, so now this will create a grid which is about 3 by 3. And the ones that are filled in, not dots here, are gonna be purple. And so now it's pretty easy to make these different tetrominos. So for example, I could just add another one here, which is T2. And I guess we'll rotate to the right. So that's now T2. And then I have to reassign, you go to T2 and you go to T1. So there we go. Let's just make the rest ones. See if it works here. T3 will rotate like this. And you go to T1, you go to T3. And then T4 is pointing to the left. And you go back to T1, you go to T4. There we go. And we can also have, let's say, you rotate so rotate, essentially we just set static is equal to static is equal to self.static.next rotation. Yeah, actually this could be a pointer. Yeah, this let's make this a pointer so that we always use the same things. It doesn't really have to be a pointer, but whatever. And now we probably, yeah, then you need to be a pointer as well, so we have to do that. Is this a YouTube video? Well, no. Well, I mean, it's you know, it's a live. Can the whole thing be on a stack? It depends on how large, like the stack has a limit. I think in Linux, the standard limit is like 10 megabytes, if I don't recall incorrectly. Stack size Linux. It's like, okay, it's like 10 megabytes or 8 megabytes per thread, I believe. Something like that. So if your state can fit in that size, then yes, you can have everything on the stack, which is way more efficient. You don't have to deal with allocators, but then you have to deal with, you know, you can't have like dynamic. You can sort of have dynamic data, but you have to kind of always specify like a maximum, you know, maximum amount of stuff you can have. Or you can use the stack. You can use an allocator that's actually using the stack as well. So you can pass around an allocator whose implementation actually puts things on the stack instead of putting it somewhere else. Which exists as a built-in thing. I think it's like heap stack fallback allocator. So it's using the stack until you've used up all the like you specify a size here. So let's say you specify the stack size. I don't know if you can get this here. Stack size. Stack. No. I don't know. Maybe there's like a way to get the stack size. Memory. Stack. No, I don't know. But let's just like 8 megabytes. So let's say you make this here. Now, if you're using, so if you use up all these, wait, this is 8 megabytes. This is 8 kilobytes. This is 8 megabytes. So if you use up all this data, it's going to fall back to a heap allocator. So you can use this for allocating a bunch of stuff, and then you don't need to think about. This makes it so you don't really need to think about where it's stored. You can use a different like implementation. As long as you use an allocator, you should be good. If you use a stack, we can bypass the 10 megabyte limit. I mean, you can't bypass the limit of the stack. It's just that you're just not using the stack anymore if you go over the limit. Yeah, the stack allocator has a limit. You specify the limit here. But if you specify a limit here which is higher than the actual limit of the stack for the operating system for this process, there's gonna be, you know, the operating system is gonna say there's gonna be like a stack error, some kind of stack error or something. But if you're within the limits, then it's good, and you can just use this. And as I said, if you try to allocate something and you already used up all of this data, all of the space in the stack, fallback allocator that's on the stack, then it's gonna start to allocate stuff on the heap. Or, you know, whatever allocator you're actually using. So it's gonna be like stack fallback, and let's say we have like 8 megabytes, and then you pass in a fallback allocator, which is usually like a GPA or something. So you can pass in a GPA that will, or a page allocator or whatever, that's gonna put it on the heap. Okay, so what are we doing here? So we have all the stuff. Now I want to, so we draw that grid. I want to draw now another grid, which is going to be the active tetromino grid. And the position is going to be, so it is the grid position. I think it is, yes. So maybe it shouldn't be. No, this is a pixel. No, it's not. It's a grid position because it gets multiplied later. So yeah, that makes sense. We could also say, we could also make this be a vector 2 of usize. That makes more sense because that's a grid coordinate and not a floating point coordinate. And so P would be vector 2 init. Can we init from usize? No, I don't think so. So this is gonna be, you know, float from int. Well, let's just make a convenience function here. v2rl is gonna be a function which is gonna take a vector, which is a vector to usize. And give us a Rayleigh vector. And we'll return init float from int v0, float from int v1. Okay, so this turns our type of vector to a Rayleigh vector. And now we can say here, we can say v2 Rayleigh position. But before we do that, actually, we could, instead of doing add here, float from int x, float from y, from it, we can just actually remove all this and then add here instead. So there we go. So that will do that. I'm not entirely sure if this is gonna actually get the correct type. We're gonna have to see that, but that's how you could do it as well. Because that's like two vectors. Zig allows plus, minus, and like times, like multiply, divide, and some other operations, compare and stuff, for vectors as well, which is pretty cool. So that's significantly more easy to read, I think. And then let's see, so the position then, so now you're 0, well, we can just pass in 0, 0 here. Now this one will be active tetromino position, which I'm gonna change out into a vector2 use size now. And yeah, exactly. So you're the grid position. Yeah, so that should be fine, because this is 0, 0. This should also be 0, 0. I think that since we're starting out at 1, I'm gonna start you out at 1, 0. Or actually, it's probably gonna be the center, actually. So it's gonna be like game width, board width over 2. Except we div floor this over 2. We draw that grid. Now let's see if we got any issues with that. No, I don't think so. Or we did. Type of declaration. Oh, next T2. Wait, what's the issue? Dependency loop with length 8. Oh. Oh, so they depend on each other, right? Okay, so that didn't work. What? I mean, that means that we have to... Well, actually what we could do is we could say, instead of making these declarations, we can make them into fields. So we'll have like T1, T2, T3, T4. And then this is going to be mutable. Wait, no, we'll have a mutable. No, actually, it could be a constant, I think. Tetrominos. And this is a instance of this where we set you to be this. So let's make a macro here. And we'll do that. And then we'll go here, replace you. All right. So that should work. And then this will be tetrominos.t2. Hopefully this works. And you will be T1. Nope. Something else. Is it the same issue? Okay. I thought that this might have been, might be working, but nope. Since now it's like this has a pointer, this has an address. So this is like a relative address from this. So I was thinking like maybe if we have this thing and we can refer to it, we could make this like a lazy address and it would be like resolved later to be correct or something. I don't know, but okay. Anyway, let's just make this a mutable. And then we'll just skip next rotation. We'll set you to be undefined by default. Oops. And then we have to update this later to say that T1. Actually, could we do this in comp time? We could also have init rotations. And so, yeah, now we can do this because now we have an actual thing there. I mean, there's probably another way to do it. Like, we could also just have them in an array and have the rotation, not worry about these pointers. I don't know. Global variable contains reference to content var. What? I've never seen this issue. Global variable contains reference to time bar. Is it these ones? Okay, maybe we need to do this in another way. So instead of having a next rotation, let's remove that. Let's just see if that fixes the issue. No? But then let's take this back into... Let's actually just undo all that stuff. Okay, now we're back here. But let's remove next rotation. Okay. And let's just remove it. So they don't have any reference to each other. Oh, we still get this. Or... Global variable contains reference to time var. Is it because of this? Like we're referencing this? Yeah, okay. So how do you build a, like... How do you build this up then? Maybe instead of making an array, we make a slice that we constantly append. That could also work. Like, let's say this is a slice. We start with an empty slice. And we say... I mean, I guess it's still a time var. But let's just try this now. So cells equals cells plus. And this has to be a... This has to be like a... well, for one, I think this has to be const. And then you have to be... a list. And it's going to be a slice const cells. Well, let's just make new cell is a slice of const cell, and it's gonna be this, and then you get added onto there, and then you are just cells. but they need to be mutable. But these are actually not mutable. Right. Okay. So we could essentially... Okay, this is the issue. We have a version that is mutable and then one that's not mutable, maybe. I mean, technically, we could make this into a function, actually, that says that mutability... Whoops. You are mutable or immutable. And that gives us a type. We return. And this one is like if mutability is equal to mutable, we get a cell, otherwise we get a constant cell. And, well, I guess if it's immutable, if it's, yeah. Now you are mutable. I'm not sure about this pattern, but we'll see. And you're immutable. Okay. Right, these are immutable, so they should be static, immutable. Yes. Okay. Draw a grid. Now, this should work on any type of grid. So essentially, what you could do here is just say any type and it will still work. The problem is we don't get like auto completions for the things. Right, and this actually needs to be typed here, unfortunately. But you can make convenient stuff for that as well. And here as well, this is going to be at this instead. Make it more convenient there. Okay. Okay, and now it just works, except the data looks a little bit weird. Okay. Huh. What the hell? Right, the index should go from like top left, right, to bottom right, so it should start at like the first one. So it makes sense that the grid, I mean, yeah, the cell, it should be the same layout as this thing here. So I'm a little bit confused actually why that's not working. I wonder now also if we can make this back into an array and still use that the way it was before. So if this is length of cells and it's undefined, and we say I'm gonna do new cell is this instead. So we get this back, but you are a new cell. And then you have to be that. Is this still gonna say a comp time bar? Okay, sure. Can we like const cast this? Or something? Const cast. Const cast cells, and then take the pointer of that. Oh, remove the const. Or can we do like as const cell? Okay, now let's just go back. So this would be cells. We have to do this, and you have to be this. Okay. Kind of weird how that works, but okay. I guess it's just because they don't want to have you can't get mutable data from comp time into runtime, so you can mutate comp time data from runtime. Like that doesn't make sense. But getting a read-only data you can definitely get. So this is a way to get read-only data here. Wait, expected. Why does this not work now? Oh, it's const. It needs to be const. Right. There we go. Okay, but there seems to be something wrong with this thing. Why is that happening? What if we change to like T3? It seems like the first two rows are correct, but the third one is actually what's weirdly not correct. T4 should be the left, pointing to the left. Okay. 2 should point to the right. Wow. Huh. What the hell is happening? I mean, it could either be something with the parse function, or it could be... Yeah, so the length... No, that doesn't make sense. Index of this. Do I need to subtract 1 on the width there, I think? No, because this should appear... So we have 3 things. The first is 0, 1, 2, and then this appears at 3. So the width should be 3. Same with this. Height. I mean, we could try subtracting 1. I don't think that should mess things up. No, it does mess things up. Oh, because this can be a... Okay, let's just do or else source length, and then this whole thing is -1, but then we don't need this. Yeah, okay, whatever. We don't have that case now anyway. Right. That's not the issue. No, I'm pretty sure this was correct, yeah. And then the height is the same. It's like, how many new lines do we have? Plus 1. That's gonna be... Yeah, that should be correct. Okay, what I'm gonna do one thing here as well. I'm gonna log out the source, and it's going to be... I'm going to surround it with quotes, so we can see exactly where it starts and where it ends. Oh my god. Okay. So we've got dot hashtag dot new line dot hashtag new line dot hashtag new line. Yeah, that seems correct. Because there's 2 new lines, there's 3 rows, so it should be new lines plus 1, right? So it doesn't add any weird new lines or spaces or anything in between. Because of the multi-line string. Oh, wait, I know what's going on. We're going through the length. We kind of skip. Okay, the new lines is the problem. The source includes the new lines. So that's the issue here. Because I'm like parsing the new lines as actual grid values now as well. So, I mean, a simple fix would be to say if... Well, that's not a simple fix, but I was thinking immediately I was thinking about iterator. So let's make an iterator, which is going to be a split scalar, and the buffer source delimiter is going to be new line. So we're splitting on new lines. Instead of doing this, we're going to do while iterator next, we get a line. So this is now a line instead. So this is, or a row, I guess we could call it a row. Okay, and now we loop through the row. So we loop through, let's do 0 to row length. I mean, we could also do width. That should be correct. Here we got the X. And to get the index now, we have to say X plus Y times width. And what is Y? Well, that is going to be whatever we have here. So Y plus equals 1, Y equals 0. We have to make it a U size, I'm not sure. So we'll have a loop for this and a counter for the iterator. So now we're skipping past the new lines. The new lines are not part of the data anymore. And instead of looking at the source, now we look at the row. Actually, we don't need to do this okay, actually, yeah, we don't need to do... Well, actually, we do... No, we don't. This is the index. We don't need to worry about Y because the row is only... It's not the whole thing. It's just a slice. It's just a row. So we're going through each row. And then the cell is just appended, so we don't need any positional information there anyway. Okay, there we go. So now we're skipping the new lines. And we don't even need this calculation. cool. How does it look now? Okay, there we go. Okay, that was a silly mistake, but there we go. Cool. And let's do... Let's see... yeah, let's just see. So T1 should work. Yeah, T3. And T4. Okay, cool. So now let's see. So what I'm thinking is that I want to make this move down. So we'll have a timer here. Next fall step at, and I'm gonna say it starts at 0. We'll have a function update function that gives us a, well, we don't really need to fetch the time because time is actually like raylib gives us a way to get the time from anywhere. But this could be self game void. And let's see. So we're checking that if this is more than or equal to get time, then we need to we need to call this false that function. Which will essentially, what I'm gonna do here is first move active tetromino down 1 step. 2, check for collision with board. 3, if there is collision, if there is collision, then we have like 3A, move active tetromino back up. 3B, add tetromino to board grid. And 3C, spawn new tetromino. Okay, and then we have 4 is else. We will just, yeah, we don't do anything actually. We just continue. Okay. Actually, also, there's going to be extra things here for checking for if a line has been completed. But let's do this first. So first we'll move the thing down. Okay, so essentially it's just going to be active position plus equals 0, 1. That will move it down. And then we need to check for collision with the board. So is collision is going to be check collision. So if there is collision, then we do a bunch of stuff. This is called top-down programming when you do it like you don't deal with the details first. You deal with the high-level stuff first, and then you kind of implement the functions as you go, which works sometimes, and sometimes you want to do the other way. I constantly shift between different ways of doing things. If there's collision, then we move the tetrometer back up. So we'll do negative 0.1. We can also call this up. No, down. I mean, we call it down. And we move it down. And we undo down. Okay. Then we add the tetrometer to the board grid. So this is like, I think what we do is we have a function on grid, which is like add, and then another, and then you do like another grid and a position. Which will just add the thing into the grid at that position. Okay. And then we will spawn a new tetrometer. So active tetrometer equals, and I'm just gonna say self new tetrometer. Okay. And otherwise we don't do anything. Cool. So if we can make all this, we have like a thing that's, we have a fall step that like moves it down. I'm kind of moving ahead a little bit, I feel like, because the first thing that I wanted to do was just move it down. But what we could do is we could just comment this out for now, and this is the only thing that's happening. Now we have to call this function every second or something, like everything happening there. So we fall step, also we have to reset this timer. So this is going to be get time plus whatever time a fall step should be. So it's fall step time or duration or something, which we don't have. Also, one thing you can note here is that, let's say there's like a tiny discrepancy between you know, get time and the actual step at. So instead of setting it to equal get time plus fall step, you can also just say plus equal fall step duration, which makes it so that you get an actual, the real yeah, so let's say this took slightly longer or something. You get the actual real timestamp at when it should happen. However, the problem is like you have to, like, let's say you unfocus the window and then you refocus the window, then sometimes it works like you're gonna get a whole bunch of fall steps at one point. But whatever. I'm willing to accept that bug here, I guess. We need to define this fall step duration here. We'll see if we get that issue. Fall step duration. Let's just say it's in seconds, so let's just say 1 second. Actually, this should probably be, we should probably have like a difficulty level that changes the duration over time, but let's have it as a constant for now. I'm constantly thinking ahead. Like I don't like that. I should just focus on the next thing. Okay, so now that should work. We just need to call this update function from the main thing. So I guess we'll do it after drawing, maybe. Sure. Game update. Or wait, no, should we? No, we're doing it here, right? Because we get the time first. I don't know. Let's do it here and then draw later. I'm not sure what's the best. Okay, so now if everything works, this tetrometer should be going down, and it's not. Okay. So why is that not happening? No, this should be less than or equal. This should be less than or equal, I'm pretty sure. Okay, there we go. Now we get it falling down here. Nice. Okay, Cool. But if we see it fall down, we can wait until it falls to the bottom. Then it's gonna like go straight through. If we have the patience to wait. Yeah, it goes straight through. And then, oh, I was thinking it's gonna be some kind of error here, but yeah, okay. There we go. It just goes through and we get a bunch of bugs. So let's now implement check for collision. So this one is interesting because it has a bunch of dependencies, but let's do the top-down version first here. So this will be game. We don't need to have it be mutable, and we'll have like a bool. Now, what we'll do is we'll say actually what we could do, I just realized, we could say we have a grid, and then if we add another grid to this grid and then check for any values that are greater than 1, we could do that. However, it's probably more optimal to just say have a special function that checks for collision. So I'm just gonna say check collision here as well, and I give it the active tetromino grid and active tetromino position that it can use to add as well. But this will be a special thing there. And there's no member or function named check collision in grid, so let's implement that. Check collision. And we have another grid. And actually, this grid is an any type because it can either be mutable or immutable. It doesn't have to be the same type as this. And then we have a position as well. And you just return a bool. So essentially, what we're gonna do is we are going to just loop through 0 to grid width. I guess it depends. No, that's fine. Let's do that. That's X. Excuse me. And then grid height. This is Y. Oops. Okay. Now, what we'll do is we will convert this into a position in our grid. So I'm gonna say this is gonna be position plus vector 2 usize with X and Y. Okay. Now we have a position in our grid. However, we need to guardrail here because we could potentially be outside of our grid. So we have to check if this is a valid position. So I'm gonna make a function call. Is valid coordinate X, or let's just have this as a vector here, and this gives a bool, and then we'll just return if position X is more than or equal to, also we need self, is self of width. So either that's true, or we can also be higher than height. And we don't need to check if we're below 0 because these are unsigned integers, so they cannot be negative. Cool. And let's see. So if is valid coordinate P if it's not I usually do this, like if it's not valid, then we just continue, right? Now you can optimize here as well, but it's not going to be that much to optimize here. It's just if it's not valid, we'll continue. If it's valid, we're over here, and then we'll say if grid get cell, and actually here we can actually just pass in x and y, because these are what's part of this grid here. So we can pass, those are from this grid's coordinate system. So we can just pass in x and y here, and then we'll take like value, and then plus, and then self get cell, and now we should use p0 and p1 because that's our translated coordinates dot value. Now if this is more than 1, then we have a collision, so return true. But otherwise, if we get through everything without finding any of those collisions, we return false. Okay, so I don't know, this feels like a kind of inefficient way maybe to do this. I don't know. There's probably tons of examples of how to most optimally find, you know, a collision based on a Tetris thing. But yeah, this was the first idea that I had, popped into my mind, and I went for it. So there we go. Let's see, grid, found this. Oh, I see. We should use the const version here. We don't need the mutable. Actually, let's get other cell. Our cell. And other cell plus our cell. It's more than 1, then we're true. There we go. Okay, so now that's implemented. We have a way to check the collision, and we can actually do this now, except we don't have this add function and we don't have this new tetrometer. So I'm gonna disable this for now, and we'll focus on the add function. So let's make this add function, and it's gonna be pretty similar to the other one. So this is gonna take a grid and a position. Okay, and I'm gonna copy this, put this over here, and essentially everything is the same except that, I mean, add is kind of weird. Maybe it should be like set instead, because we essentially don't want to add it if it's yeah, let's do set instead. As, or wait, what's it called, like union? Let's do union, except union is keyword, so that doesn't work. God damn it. Union grid. Yeah, let's just call it union grid. So that's probably a bad name, but whatever. So we don't really worry about our cell actually here. What we do want is the pointer to our cell though. Because we want to set. Actually, there's a difference here as well, because if the value of the other cell is 0, that means it's empty. So that means we don't want to set that. So if other cell, actually I'm gonna go back to call this add because of this. So because it's kind of like an add operation, because we don't add, the zeros don't become zeros in our source grid, if they were 1 before, we don't set them to 0, we keep them as 1. So essentially it's like an add operation. So if the other cell is 0, then we also continue. Actually, there we go. Other cell. It's actually like a value. Like, I'll just call it value. Actually, we need the whole cell, to be honest. So we'll check value because we need the color. Like if we're actually setting it, we need to actually do that. Also, we have set cell. So there we go. P0, P1, and the cell is going to be the under cell. Okay, there we go. And we don't return anything. So that's the add function. Cool. Now we go back to our place over here. So now we should actually be able to actually run this and see that the terminal should go down and now combine with the game. Let's make it fall a little bit faster actually, so we don't have to wait for that too much. Okay, okay, we got some issues. Why did it quit on me here? 73, 90. Our cell is okay. So apparently this was out of bounds. Right, because it kind of went through, as you could see, like it went through the thing, and then we check collision. Apparently, it's still valid, so that's weird. Did I do something wrong here? Either position is more than we got the width, or 1 is more than we got height. Is this the wrong position I'm sending in? No, it's P, which should be the result. Position. Wait, this is the other way around. This should be less than. And I'm basically checking if it's an invalid chord. Okay. Okay, there we go. Okay, so it landed there. It became part of the board, and now we should. Now the next step is to spawn a new. The next step is to spawn a new tetromino. Cool. So we got that working. I was worried that was gonna take a while to fix that, but that was good. So now we need a new tetromino. So let's make this function new tetromino. Okay, so I'm thinking here is that this is going to... do we need this mutable? I don't think we need a mutable here. And this gives us a... Well, I guess it gives us a tetromino. Yep. And what I'm thinking here is that the static, like the type of tetromino is going to be randomized. So it's going to be... and for randomness... in zig now in 0.16 you need the IO. Well, does this still work? Because the crypto thing has like a random. No, I guess it doesn't work anymore. So you have to actually use the IO interface. So we have to add IO here. It's not a big deal. You just have to have this IO thing. And you actually get it from init now, from main. So every program has this. And we just add IO here. And basically IO is used for like non-determinism, like if you, or like side effects to the file system or network or stuff like that. So it's like everything that is non-deterministic essentially. So random numbers are non-deterministic, so that would be part of IO. So we get the IO here, and we need to use this as a thing for us to be able to use. So IO we get from init.io. Now this IO is a, so you can have different like implementations of it as well. This is using a default implementation from main, which I believe is the threaded implementation, and you can also use it. You have to use IO if you want to spawn threads or do some async operations. So, but yeah. Anyway, okay. So we have this IO here. What's your issue? Okay, you're doing this. Yeah. So now we're here. So now we can use IO to get like randomness, and I think also we probably need like a random. I'm not sure if we need a random. This is the question, if we need a random instance or not. Because no, this is not how we do it. You do it like standard IO and then random. No, it's random IO. Yeah. IO source. IO is IO. So this is the random thing. Now the thing is, like, I'm not sure if you actually need to have this. I don't think you need to have this like constantly as a like store this somewhere. I think because it just has IO in it, so we already have IO. So I think we could just make this, have this random thing happening here. I wish there was a convenience function on IO to get a random instance from this thing, but there's not. So you have to do this to get a random instance. But now you have this random instance. Now we can say, for example, we can say interface, and we can say boolean, for example. I'm just gonna double check here. rint, and this is random. And bytes. Okay, so this calls like IO bytes. I think. No, it doesn't. It fills. It has a fill function. Okay, I'm not sure. Anyway. Let's see. 1 second here. You are banned. Thank you. Okay, anyway, so let's go back. I'm just gonna do this and try. Now we only have like one tetromino now anyway, so let's not worry about this for now. And I'm just gonna return a... No, I'm gonna return tetrominos T1. Okay, so that should now constantly spawn a bunch of T1s. So let's see if it works by stacking it up now. Okay, it does. However, you can see that there's kind of like a bug where we draw the black rectangle. I actually didn't foresee this. It's kind of funny. So it was better to not draw the black rectangle. So what we're gonna do is we're gonna say if the cell value is 0, we are going to continue and not draw this thing. Yes. So now we shouldn't see that shadowing happening. Oh. Well, okay. So this is an issue of not clearing the screen here. So we need to clear the screen with black. You could choose another. I don't know if we're gonna choose another. Let's just use black for now. There we go. Okay, now it's stacking up there. Okay, cool. So let's now, what should we do now? So we could introduce new terminals, but that we could do that later as well. I want to actually be able to, let's just let's do some input. So I want to be able to move the terminal to the left and to the right. So let's make these functions first. So let's do like move left. Okay, so so this would just move it to the left one spot. So I'm gonna do the same kind of thing here. So one, move terminal to the left. Two, check for collision. Three, or yeah, if collision 3A, so move the terminal back, and then we basically don't really need to do anything else, because it's just like we're undoing the move since there was a collision essentially, and then otherwise we don't really need to do anything either. So this is essentially all we need to do here. So let's move the thing to the left. Position negative. So let's have left be vector 2 usize. And that's going to be -1, 0. Now the issue here now becomes, because this is a usize, so we can't actually represent left with a usize. This is the issue. However, we could say right instead is 1, and then do negative equals right. And then another trick here to actually guard against, I guess, underflow or whatever it's called, whenever you go below 0 if you have an unsigned, is to actually just say this operator here, which is a modification of the minus. So this is a specific minus operation, which says that if there is an overflow or an underflow or whatever, if you go below 0 and you're not supposed to, if you have an unsigned value, then you stay at 0. Or if you try to go over the max value, you also stay at the max value. Now there's another operation that is similar, but it's this, which does the other thing where you actually wrap around instead. So if you go below 0, you will wrap around to the max value, and vice versa. If you go over the max value, wrap around to 0. But I'm gonna use this because I don't want to wrap around. So this will guard against going, below 0 there, so we don't crash the thing. So there we go. Now we can actually move to the left there. Okay, and then we check for collision. So this, we already have this here. So we have is collision, check collision. And if we have a collision, then we will move the terminal back. So position, now we add right instead. Now we don't really need to worry about overflow here, because it's such small numbers. Okay. But you could add the guard thing here anyway if you want. I'm not sure if it's more like, more optimal, or if it's, because if you don't have this, zig essentially adds a check to see if it goes below or not. If it goes below, it's gonna panic. So there are some computational inefficiencies there, but if you do this, then the check, I guess, I'm not sure if the check is there or if it's using some kind of special operator for this specific type of operation. But anyway, now the collision is checked, and if it's collided, we go back to the right. Okay, so then we can also have the same for move to the right. And once we've done that, we could see if we can merge these two functions, because they are pretty similar here. So instead of left, right, it's going to be left. And left is, well, okay. We still need to use right here, but we need to change you to plus here. And then minus. Here we don't need this because we're going back to where we were, which should be a valid position. Okay. Right. So now we have move left and right. Let's just keep it separate. Whatever. That's fine. Okay. So yeah, and there's no, there's no move up, of course. There is, there's the drop where you can drop it to the bottom. But let's see if we can make these work here first with the first input here. So essentially, I'm thinking we could probably have it happening the first thing. We could probably have it in the game update, actually. So if it's time for this, we call full step. That makes it actually merge. And then we get a next tetromino. And then we can check for input. So if raylib is keyed down, I'm just going to use keyboard here. Actually, I'm going to use pressed, because pressed is like an edge detection. So it's going to be true the one frame where you start to press a button, and it's not going to be true subsequent frames if you still keep holding it down. So it's going to only trigger once for each key press, essentially. If you use key down, you're going to get a bunch of true events every frame as long as you hold the button down. So we're going to use pressed here. And so the key, I'm going to use WASD. So A is for left. And so this will be self move left. And then we can have one for D, which is move right. There we go. So now I think we should be able to move left and right. Yes. Okay. So now we have we're almost there. There's a couple of more things. There's the rotation, which I think is probably one of the most advanced things in the game. But I wonder if we should do that now, because we could allow rotation, but then there's gonna be kind of bugs, I think. But let's do rotate now. So rotate. Okay. Now, what are we gonna do here for rotation? Yeah, so first thing is, like, we don't really have a way to kind of rotate yet, because these things are actually don't have like a reference to each other anymore. So what I'm thinking instead we'll do is we'll have a list. So T is actually going to be a list now of tetromino static. So I'm going to make you into a list of constant tetromino static. And then we'll simply put all of you in there, and we'll make a macro and we'll basically remove you, do that, do this, go down, and there we go, I think. Okay. And now you are instead T0. And actually, well, let's do this later. So, does not support array initialization syntax. I think if we do this and then this, that might work. Or we could just do this, I guess. Yeah. Because now we have a way to actually rotate them. Because we can say that we could do like rotate and then actually no, let's see, we have rotate on this guy, rotate tetromino, actually it's gonna be kind of weird because this points to one of the elements here, so it doesn't actually know which like class we have actually. We could also do this. We could make so that we could say that tetrominostatic has not only one grid but actually a list of grids, constant grids, immutable, and a color. Wait, it doesn't need a color because it's like baked into the grid, but we can have a list of grids, and then here, instead of having like, yeah, the static is the static, but then the variant is a U size. Okay, and then you can have a variant. Okay, there we go. And now for rotate, we simply say variant plus equal to 1, but it's going to be equal to variant plus 1, but then we mod this by static grid length. Also, let's add a convenience function to get the grid. Return static grid self variant. Okay. Because now you are going to be T instead. T is actually going to be a tetrominostatic. We're going to remove all of this. I'm gonna call your grids. And grids is gonna be a list. And then we're parsing a bunch of stuff. Whoops. Okay. You go there and you go there. And you need variant 0. Okay, yeah, because now we say grid like this instead. All right. Rotate grid. Yeah, you are immutable. There we go. And this is wrong. You are, I'm just gonna say 0 there. Okay, there we go. Now we're back here. So rotate, I'm gonna say, so for simplicity's sake, we're gonna do rotate tetromino, 2, check for collision, 3, if collision, whoops, collision 3A, then we revert rotation. So we rotate back. Which kind of means we need like a rotate and we need an unrotate, or yeah, a rotate and a direction. So let's actually say rotate, and then this could be like a direction, or we unrotate. We have a function for unrotate or derotate. I don't know what's better, unrotate or derotate. We'll do I'll go with the unrotate, which will give us -1, but that could, but variant could be 0 here. Actually, it can. No, yes, it can. It can. So if variant is 0, we will, oops, simply set variant to maximum and then return. Otherwise, we'll set it to -1. Right, yeah, well, yeah, we just -1 there. So we have to have this guard because it's unsigned. Okay. So rotate tetromino. We should have this now. So active tetromino rotate. Yes. Check for collision. Check collision. If we have a collision, then unrotate. All right. Now we go back to main. No, we go back to update. And what key should we press for this? Also should be able to like rotate left and right actually. So I'm gonna say E is rotate, because that's kind of like rotating right. I don't know. Actually, I don't think Tetris usually has a way to rotate both ways. I'm just gonna do one way for now. Okay, let's see if this works. Okay, there we go. It rotates. Cool. Yeah, I can stack. Look at this. Okay, and now here you see something that is kind of missing. And we can't move into... If I'm at the edge and I try to rotate, it doesn't work because... yeah, because we just deny the fact that we are trying to rotate here. Okay, cool. So we have the rotate. Well, you know what? I'm gonna add another one, which is pretty simple. This is gonna be like, if I want to speed up moving down, I'm gonna have S, and this is simply gonna just add a fall step. So a manual fall step there. So now if I press S, I can speed up going down. Actually, I just realized up should probably be rotate and not E, because I was instinctively pressing up instead of E. I'm not sure what drop is going to be. Probably space or something. But okay, so we've got like move left, move right, rotate, fall step, and what else? I mean, we need the rest of the tetrominos. We need the randomize which tetromino is gonna be spawned next. We need a line. The line clear. Let's do the line clear. Okay, so the line clear. The line clear. So let's see. Should we have a special function like check for line clears? We should probably like, okay, actually this is the only place where we kind of edit the grid, and that's when you could essentially have a line being cleared. So what we could do is we could say check line clear here, or like handle line clear or something like that. I'm just gonna say like handle line clears, and we'll do, I'll add this here, handle line clears. Now you need to be mutable. Now there's not gonna be any animation or anything like that. It's just gonna be very extremely simple. It's just gonna be immediately clearing the line. It's pretty, I mean, I think it's pretty simple to add animations later, but I'm just gonna do the most simple thing first here. Hey Code Guy, what's up, what's up? Oh, Raylib, finally. I'm also learning Raylib and C#. Okay, cool. Raylib and C#, does it, how does it work with C#? Does it have like bindings or something? Okay, so, I mean, I know it's a C library, so, but does it like, yeah, anyway. I've never used a C library with C#, but maybe that works somehow. Okay, so handle line clear. So, I mean, I guess you could just import, you should be able to just import like any library or something, maybe. I don't know, because C# feels kind of contained. It's same as C++. What do you mean? So, right. So what we need to do, I think, is we need to go through each line and check. Do we need to, should you be cleared? And then it's gonna be like, because the thing is like, you could get a line, like let's say these are empty here. I'm just gonna do 4 white for simplicity. But let's say you have like, this line gets full, next line is not full, but then this gets full. So then you have 2 lines that should clear, and then the rest of the line should kind of collapse and become, you know, move down essentially. Everything falls down essentially, but it should fall down in the correct way. Binding shits and learning for first time, I bet. Okay. I mean, are you I guess you're following some sort of tutorial Raylib with C# or something? I didn't know Raylib had like worked with C#. Oh, there are C# bindings for Raylib. Okay, nice. Why are you not using zig though? That's the real question. All right, so let's see. To me, this is not really super obvious right now. Not like yeah. So I mean, is this actually, this is like a value. Can I just do this? I could actually have this as a sort of weird comment here. Okay, you are not used, right? Okay, there we go. Zig feels hard. Yeah, it's not. I mean, I guess, C# has garbage collection, so in a sense, it's easier. But yeah, I mean, yeah, it's a, you don't have to worry about a bunch of weird stuff that you have to worry about with manual memory management, I guess. Yeah, that's fair. That's fair. But one day you will learn. Because Zig is the best. No, but yeah. Handle line clear. So what do we do? We will, I mean, we could do like a simple recursive thing. But that seems very inefficient. But it's not going to be that much going on though. Like at maximum, there's going to be like 4 recursive things happening. So I'm just going to do this one by one per probably. I'm going to start at the bottom. No, I'm going to start at the top because then you move the least amount of lines. Yeah. So we'll start at the top. 0 to grid height. Okay, we get Y here. This is the row. So we're gonna check if is line Y, then, well, if it's not line, we don't care. Continue, please. If it is a line, we continue here. What we're gonna do here is we're gonna just apply this algorithm. We're gonna clear this line, move everything down. So essentially, we move everything down and then a new line is gonna appear at the top. So move grid down and it's gonna move down at Y, I guess. So this line is pretty simple. I'm gonna do move grid down first. And then in row is gonna be, this is gonna be 2 row Y, wait, not Y, U size. Okay. So I think here we're gonna loop through from this to row. And then the row that we're currently affecting should be Y minus, no, 2 row minus Y minus 1. That is the row that we should currently move down 1 step. So row is going to be that. I might get a call here at any point in time, but I'll continue until I get a call, and then we'll take a little break here. Just so you know. Okay, so row should be the row. Yeah, that's the row we're moving down. Or is that the, no, yeah. Because if 2 row is 1, that means that 0 needs to move down 1. Yeah. And then that becomes 1, that becomes 0, -1, then the whole thing becomes 0. Yes. So we are going to loop through 1 row, and we're going to say grid set cell x and row. No. Row. This is going to be the target. This is row +1. And this is going to be the thing that we move, the source. Okay, so we set the target to be get cell x source. We set the target to be the source, right? Makes sense? For all those x's. Okay? And then we do that for every row moving upwards. We essentially start at the bottom and we move upwards. Because then we don't, in that way, we do not lose any data. Now, for the top row, the top row also needs to be handled specially here, because otherwise it's just going to be copied down 1 step. So the top row is going to be 0, and it's going to be set to well, it's going to be empty. You can make a thing here where this is the empty cell, or you can make also, I'm gonna call this wall. So now we can say that you should be empty, and then, but if, actually let's do 1 to width -2, because that sets the middle part. And I don't think we need to worry about the walls actually. Yeah, we just empty the middle part because the walls should stay the same. Hello Phil, what's up, what's up? Tetris, is that color blocks right? I'm pretty sure you know what Tetris is. Yes. Will you dig it deeper inside OS development in future? Probably not. That's too, like, I don't know. That's not really what I'm interested in, to be honest. Row. Oh, that's source now. Yeah, there we go. So we're moving the whole thing down. This doesn't feel like a very efficient way of doing it, but hey, it's probably not going to take that much time since it's just a couple of lines, you know. Okay, no field of memory is line, right, so we need this check here. So we need isLine row is usize. We get a bool back. So here we essentially just check for 1 to self-grid width -2. We get an X. And we just want to check if the grid get cell const X row dot value. So if we find a value that is empty, also we could also add a convenience function here. We could say is empty. Oops. Bool cell this return self value is 0. Okay, so now we can say, instead of saying this, we can say is empty. If it's empty, then there's not going to be a line, so return false. But if we exhaust the entire loop and didn't find a hole, then it's a line. All right. And yeah, and that should do it here, I think, because we go through each line, we clear it, and we move everything down to that line. So let's say we do this here. I'm gonna go through the algorithm here. So we go to line, we go to this row, which is 1, and check it's a line. Okay, we move everything down. So this basically gets copied over this, right? And then we continue down here, and this is a line. So this gets copied over here, essentially. Yeah, that should work, hopefully. Okay, so we handle line clears. Now, do we call this? Yes, we do. We call this after here. Okay, let's see if this works now. Hello, Sokna, what's up? Oh, okay. It cleared the floor for us because it's a line, right? The floor is a line. Okay, and then we created a hole which you can go through. But so actually we need to stop before the floor. So we don't include the floor in checking the line. Okay, there we go. And let's, boom, hey! That's such a nice feeling when something actually works. Okay, I'm just gonna see if I can make like multiple lines. Actually, I can't really make that happen right now. Can you actually make multiple lines happen with a T? I think you can if you have a dip. You have a T-shaped hole like this. And you fill in the rest, and now we should get 2 at the same time. Hey, it works. Cool. All right, Sokna, that's fine. But how fun is that? Okay, and how much training do you get with programming when you do that? I mean, I use AI for stuff, so I'm not anti-AI, but you know, sometimes you want to have fun making a project as well. Okay, so that is now done. What we can do now, I mean, now we can basically do the rest of the tetrominos. So we can do like, this is the T. I don't know what they're called actually, but let's do like, I don't know, L. L is the, or I maybe. I is the, like capital I is the long one maybe. I don't know. Let's do, how should this get rotated really? I mean, we don't really need these other parts. So this should only have 2 rotations actually. So let's do, yeah, and then the other one is just like this. And this one is, I don't know, light blue, maybe. Is that a thing? Why doesn't that work? Color light blue. That's not a color. Sky blue. Okay, let's do sky blue, I guess. That's a color. Okay, so that's the other thing there. We probably want to have the tetrominos in a list as well. I mean, we could have all tetrominos is going to be the declarations of tetrominos. And, well, that's the declaration, though. No. I mean, we can build the tetrominos from the declaration. It's just a pain in the ass. So I'm just gonna do this. All tetrominos are going to be a list. And the first one is going to be tetrominos T, tetrominos I. We can also move this in here. Call this all, and then we don't need to do all that. So there we go. And let's actually make you into a thing. You are const static. Oops. Okay. Because now, when we do like next tetromino or new tetromino, whatever it's called, why not use VS Code? Why should I use VS Code? This is way better. Okay, so we have this random IO source, random IO source. We have a random thing here. So to get the random tetromino, what we'll do is we will say return. We will get the static. It's going to be tetrominos all, and then random uint at less than usize less than tetrominos all length. So that gives you a random basically element of this list, and we can do that, so we can pass it along here. Yeah. So uint less than is giving you a unsigned integer less than x, and if you put like the length of an array, you will get a random index into there. So let's actually call this I here. Put this over there. That's good. Where and how you learn Zig? I mean, personally, I just played around with it, and I mean, yeah, I've been for some things I've looked at some examples and stuff. There's not a lot of resources on it, so if you want to go down that path, there's like limited resources, and it's you know, you have to be ready to kind of explore on your own a lot of stuff. You need self. And but that's what I think is fun with it. That's like it gives me satisfaction also to know that there's not many people doing it as well. I don't know what it is about that, but but yeah. Anyway. Okay, so we have the index that is less than the length of the array. We can get a random number there, and we use this index to get one of the tetromino types, and we initialize with that. Also the variant, I guess the variant is always going to be 0, so we start with 0 for all variants. So now this new tetromino should be giving us a random tetromino instead of giving us the same one every time. So now we should get like, well, we only have 2, so maybe it's gonna, there we go. Now we got like the long one. Okay, cool. now, also what I want to do is when we start the game, we always start with this one, but I want to get the new tetromino. However, this requires a game. So instead, what I'm going to do is I'm just going to pass IO. And instead of getting game, I'm going to get IO here, because that's really what we need here. And there we go. And then you don't do, you just do new tetromino with IO, so we can reuse it there as well. So now you get a random tetromino when starting up. It's pretty, there we go. Okay. Oh, the rotation of that one looks a little bit weird, but I'm actually not gonna worry about that for now. It doesn't need to be perfect right now. I just want to complete this with some stuff. We can fix that later maybe. Okay, let's add the rest of the stuff. I mean, I guess it could depend. Like if you add, if it's easily fixed, I will fix it though. So if we do like 4x4, actually this is 5x4. We could do like this, and then we rotate into this. There we go. I think that should solve the, yeah, that solves like the rotation there. Okay. Man, there's like a Discord thing coming up every time I start the game. That's like, hey, show what you're doing on Discord. Every time I start this game up. Okay. What else do we have? We have like the L's. We have like L and the mirrored L. So I'm gonna say L. This is going to be this one. L like this. And then we rotate. I'm gonna copy this over here. We're gonna rotate this to the right, so it's gonna go, I think it goes up like this maybe. And then also, what color should you be? I guess we'll take blue. Okay. And then we rotate like this. Makes sense. And then we rotate like this. All right, so now we have L as well. There we go. Oh. Okay, interesting. Okay, it actually became longer because I added like 4 here. That's pretty funny. I guess we just do this, perhaps. Would you explore cybersec? That's actually one of the areas that I'm not interested in at all. It has always been like one of those. No. Oh, I see. There's a bug here. I can't move these to the left because they are too kind of wide. I guess it's because the grid is actually going beyond the position there. So we can't actually have the position go beyond. Okay, I can solve this actually. Let's add a little bit of padding to the left. So I'm gonna add, I don't know, let's add like 10 just to be safe. So the padding will make it so that we could add we can add padding to the board width. It's really inefficient, but it's just a way to solve the issue here. And then when we do this, this is going to be left padding now. I should have like a convenience function for this really, but that should be left padding instead. We have to fix some stuff here. Hopefully it's not too much we have to do. This one, I mean, the thing is we could start at left padding +1 here to make it a little bit more efficient. Same thing over here. Also, we have to do it because we're checking for an actual line. So, but here we should start at left padding. And what else? Board width over 2, and then we have to add left padding as well. It doesn't have to be constant public because we're in the same file, but whatever. It's just habit here. Okay, so is this enough for us? The whole thing should be moved to the the wall is initialized incorrectly. So init board, the thing here. Oh, this should be left padding. And there we go. So now we have a little bit of left padding. Now we can move this over to the right. It's a very, very inefficient way to solve that issue, but yeah, whatever. Okay, cool. Now, we need the other counterpart to this. So this is going to be the mirrored version here. I don't know what to call this. We'll call this lowercase l maybe. And so essentially just going to be mirrored here. So instead of pointing one way, it's going to point the other way. And now I just realized that this is actually probably better if it's over here. Probably. Okay. And then maybe you should also be I don't know, because it felt a little bit weird when we rotated that one, but whatever. You get used to it quickly. So there we go. There's that one. Oh, it should be another color. Let's make this red. Okay. And then we have, I think it's just 2, no, it's 3 left. It's 3 left. We have the block. I'm gonna call it B. So the block, I mean, the block is very simple. It doesn't have any rotation. It just has these. Also, I know the color should be yellow, because that's what I'm used to. Okay. I don't remember the other colors, but this one's definitely yellow for me. So there we go. That's the block. We have the zigzags. I guess those we could call the one S and the other one Z. So S, let's see, it should be like 1, 2, 3, 4. And those also only have 2 rotations, I believe. This one should be green. And then it's gonna be like, no wait, yeah, it's gonna be like this. But I wonder if it's gonna be moving to the left ones or not. I don't know. S and then Z. I wonder if there are like official names for these. and then you're just a mirrored version. And you will be no, we have purple. We have green, yellow, red, blue, cyan. We could be cyan. Okay, is cyan a thing, actually? Maybe turquoise? No. Is it cyan isn't a thing? How can cyan not be a thing? I mean, it's not going to be white, but I'm just going to check. I mean, orange. Okay, orange. Let's do orange. Sure. Okay, so we have S and Z. There we go. That's all the tetrominos. I mean, I feel like we almost have like a complete. Isn't this like almost like a complete Tetris game now? Oh, wait, that was wrong. It cleared the line. Wait, was it wrong or was it not wrong? It cleared the line when it. Yeah, definitely wrong. It cleared the line when it shouldn't clear the line. So I think is line is a problem. Should this be -1? It should be -1. Probably. Which means move grid down should also be not working. Oh, I should also have a drop function. I just realized. No, that still works. Okay. Cool. Okay, cool. So we have like a basic, we have the basics in now, I feel like. We could add things like score and showing the next tetromino. Like getting a lot of score when scoring a Tetris. Having the difficulty like speed up the game. There's a bunch of stuff you can add, but this is like the basic functionality now. Okay, there's one thing I guess missing, and which is game over. I just wanted to play here a little bit so we can test it out. Oh shit. It's kind of hard when you don't know the next piece, actually. Oh shit. Okay, well that was... Oh man. Okay. I mean... No, this is... Wait. Okay, there we go. It's over. Okay. Thank you, piano. But we also have a project like that. Oh, cool. SGB. Hi. What's up? What's up? Also did have for understanding const was constants. Const in, well, it means different things in different languages, but in Zig, it essentially means that if you have a const like this, const x equals 5, for example, it means that this x, you cannot change it. That's what it means. You can't change it later. So you can't say x is equal to 3. SG by, okay. S, yeah. Okay, SG by, okay, thank you. Sorry. Yeah, so essentially it just means that now you can't change x here to something else. We're just testing, I know, right, const. Oh, okay. Wait, were you testing my knowledge of const, or wait, did you ask about this, or was you, or are you joking around? I don't know. Yeah, I mean, yeah, it's in the name. It's constant. Uh, bu- 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 yeah. So okay, well, even like the most knowledgeable programmer, I'm not saying I'm that. I'm just saying that even if you're the most knowledgeable programmer, there are still a bunch of gaps in your knowledge. So that's why it's kind of like when you're working with other programmers, like people find it annoying, but I always have to kind of fill in the gaps at some point. Like if you don't know the person, how good the person is, or even if you know how good the person is, sometimes there's just knowledge gaps, and you have to, and that's why I'm trying to be very thorough. But sometimes people find it annoying because they're like, "Hey, I already know this. You don't need to explain this." Blah 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 blah. But yeah, I don't know. Anyway, what do we do now? Yeah, so we could make like the game over if we could make the game over here. So I mean, either we could do something over here, we could make it into the game. You will miss out something if you need the best in the world. Knowledge, yeah, exactly. And the thing is also there's always new things coming out, so you're constantly have to learn new things all the time. But that's how I like it, because otherwise it would be kind of boring, to be honest. Okay, so let's see. Like, imagine if we were still stuck with like COBOL or something like that, or machine code. Like, imagine if we were stuck like with punch cards. Anyway, got the same project already built last year, like in August, September. Okay, cool, nice. Like with Zig as well, Zig and Raylib. Okay, so if we are game over, should we have? Let's do this. Let's have it part of the game. Actually, let's do like main state or something like this. Main state. Let's make this into an enum. Either we're playing or we are game over. Okay, so let's start with playing. And if we update, let's now switch on state. If we are playing, I'll do update playing. If we are game over, we'll do update game over. And we'll move all this crap into update playing. Okay, and then we'll have update game over. All right. Game over. I'm thinking we don't really do anything. For now, I'm just gonna not do anything at all. Okay. So now we have two different kind of modes that we... Oh, sorry. It needs to be like this. We have two different modes that we can have, playing or game over. And we start with playing. So we should just, if we run this now, it should just be the same thing that we have, because we don't have a way to kind of transition into the other thing. Low-level languages. Yeah, I made it in SIG and assembly, and also CPP. Tried 3 days was testing something. Okay, cool. Nice. Yeah, I mean, I'm not doing I'm trying to be as productive as possible, although that's not entirely true, because I'm also having fun doing some weird programming stuff. But yeah. Anyway. I'm trying to work on being more productive, because I plan on entering like game jams and stuff. So I want to work on on that, on trying like just focus on productivity first and foremost, so that you can get a game out as soon as possible and not like, you know, horse around. Okay. So let's see. We could move this into draw actually. So let's have draw. And same thing here. We can switch on state. If we are playing, we'll draw playing. If we are game over, we'll draw game over. Draw playing. And draw game over. Okay, so this should be the same thing here again, except we need to call draw here. Okay, now my brain just froze there. Okay, it still works. So now we need a way to transition these states. So update should then say that we can have a thing down here. If check game over, then we should set our state to game over. And so we'll add this little function. What is this? Draw grid, right? Well, check game over. Okay, so essentially we just need to check, are there any solid, have we reached the top essentially, I think. So if, so we're gonna loop through, let's do line, no, left padding +1 to grid width -1, and we're gonna check if grid get cell x0 is empty. So if it's not, if someone is not empty at the top, we have game over. Okay, otherwise we exhaust that, everything else we are not game over, so we can now go into game over. Okay, so what do we do with game over? We don't really do anything right now. Draw, I'm thinking we should probably try to draw something here. So let's just render text. What the hell is this? Render text or draw text. Draw text. There we go. Draw text. This is going to be very, very simple here. Game over. Position. I mean, it's 720. 720 is 360. That's the center, but then we don't know, you know, we don't know the size of this text. So what you do usually, you have like a measurement, measure text, game over. So this is the text. Oops, yeah, text font size, I guess, like, I don't know, 40. Position Y, so yeah, let's do 360, and the color is white or light gray. And this will be, so that's the measurement, that's the width. So we want to divide that by 2. So we want to do like negative div floor width by 2. Let's actually do half width. I mean, we could, if you want to be very efficient here, you could also store this measurement, but whatever, it's not gonna do that much. But this is the half font size, so we're just gonna take font size over 2. Okay, so now we should be able to game over, hopefully. Programming is fun for me. Good. It's fun for me as well. Oh man, this overlay is pretty annoying. Okay, it kind of just stopped. Oh, okay, I forgot something here. The draw function actually has to. It has to. You have to call begin drawing and drawing, otherwise it will crash like that. So let's do that here. There we go. Game over. Okay, cool. So now we can game over. We can also like, we can add then, so actually I'm gonna do draw text centered. Do I need self? I don't think we need self. We need like position. Now this is, we could make yeah, okay, let's do position is a vector. Let's do raylib vector. And this is that. So then this would be position 0, so like x is gonna be position x, but it's gonna be int from float, and the int in question is something. It's an I32. Okay. And I guess we can have font size. Actually, what is font size? It's the F32. No, it's I32. Okay. All right. And so here we'll do draw text centered. Position is gonna be 360, 360. This is gonna be 40. We also need the text, of course. All right, text. Actually, you know what we'll do is I'm gonna do format and args, because this is usually how you print like text, you have a format string, and then you have the arguments, which is an any type. And so then you can use that to, you know, provide arguments to the formatting. So you can format a string with variables and stuff. So, but to get the text, then this is gonna happen every frame, but it doesn't really matter that much. So, but now we could use, well, we could use a buffer actually. That doesn't matter. We could stack align it or stack allocate this. So let's just have a buffer here, and what we can do is we can say, I'm pretty sure we have like a writer. You could do maybe allocating, actually allocating writer and pass in. There's gonna be so much stuff here to do. Actually, we don't need this buffer then, because we need an allocator. The actually, this is stack allocator is going to be keep stack fallback, the size 124, the fallback. I'm just gonna say it's undefined. This is a little bit you know, sketchy, but I'm pretty sure we're not gonna go over a kilobyte for this. So I'm just gonna do that, pass this in. You call get to get that allocator. Okay, so now we should have an allocating writer, and we can use this now. Also, we don't really need all this crap. Actually, we don't need that. I've just that was for the more advanced. What we need is standard format, buff print, the buffer format args. There we go. I don't know what I did there. I was like totally out of line. Buffer is that. You can be an error, but we don't really care about this error because that's not going to happen. So I'll just catch unreachable there. Okay. And the text will now be the text like this. This is the text now. So we get the text from there. Okay. Actually, you know what? If we catch and nothing's going to happen here, we're just going to say error. Okay, so that also works there. And now we don't need an allocator, we don't need to allocate anything or deallocate anything. We have it on the stack instead. That works. And now we can provide a formatter and arguments here. So this should be game over. And now this should be the same thing as we had before, except it shouldn't crash. Oh, you actually need a zero terminated string. So this is usually what happens when you're working with C libraries. Raylib especially wants a lot of those things. So what you could do is just add a Z here. And now we all of a sudden have a zero terminated string instead. Division with, okay. So I'm gonna move you to a floor division instead. There we go. Hopefully I can complete this. Well, for all intents and purposes, we have a kind of like a functioning, you know, game right now. It has, you know, I guess the only, like, you would want to have score, the drop mechanic, or the drop thing. Why am I trying to play this game? I'm trying to get the game over here. Game over, there we go. So we're back to there. But now I want to add another text to say press space to restart, to start again. Or restart. Whatever. And we'll add, like, I don't know, let's add 40 and you will be 20 or something. So now we should see that centered. speedrunning. There we go. Press space to restart. Okay, so let's add that function functionality. So if we're game over, and if is key pressed space, then self restart. Okay, so we need a restart function. And well, essentially restart. We could do init board, I guess. That will like clear the entire board. Init board. Active tetromino is gonna be new tetromino. I think that's it. Like, that's what we have right now that we can actually restart, I think. Next fall step at we could reset as well, I guess. It doesn't really matter that much. Well, actually it does matter because it could be a long time. Because, yeah, I'm actually gonna show what happens if we don't do it. So if we stand on the if we stand on the game over screen a bunch of time now, and then I press space, it's gonna just fly down, or nothing's gonna happen because it doesn't work. Okay. Why is that? Oh, right. I need to change the state as well to playing. There we go. What are you gonna do after completing this? I'm gonna log off. I'm actually working on another game. Oh, sorry. Now I got my phone call, so I have to BRB here. I'll be back though. 1 second. Okay, I'm back. Sorry about that. Took a lot longer than I anticipated. Yes. Okay. Should we then? Let's just continue here for a little bit. I have a bit of time. Okay. So why is this not? Let's just see how much. We'll continue a little bit and see how far we'll get here. I want to add like score and stuff as well. Maybe difficulty, probably not that hard to add here. So update game over. Why is this? So I added the playing state, right? It goes back to playing. Okay, also I want to fix another thing as well. So press space, nothing's happening. What else is missing? Because init board should like reset the board, right? No. Okay, so we only do the walls and the floor. Oh, okay. So we actually don't need to call this. We actually need to call like clear board or something. Also, this is wrong convention. I just realized. Okay. Clear board. Let's make a clear board function. So this would go from left padding +1 to width -1, that's x, and then go from 0 to height -2, that's y. And grid set cell x, y, empty. Okay. We'll clear the board, because I think what's happening is it goes back to playing, then checks for, since the board isn't cleared, it checks, it's still game over. So it goes back to game over. I think that's what's happening there. Okay, well, what? It didn't fix the, wait, what the hell? Okay, it doesn't clear the last row, so I guess we'll include, oh yeah, because it's exclusive, right? There we go. There we go. Also, I'm gonna show this bug that I was talking about now. So if we, because yeah, if we let it go, if we let it be here on the game over a while, and I press space, you're gonna see the tetrominos instantly go down here. Yeah, and the reason is because we don't set this thing to back to 0 or something. Actually, it shouldn't be 0. It should be get time plus forced up direction. Okay. So that should fix that issue. Oops. Game over. We'll wait a little bit. Starts at the top. Cool. Now, I think I want to draw this a little bit like in the center instead of in like up at the top. So let's draw, let's have an offset. And this is like a grid offset, I think. So I'm just gonna have it be like, well, this is a vector 2 you size. So let's just say, I don't know, 10 by, how much is 720 over 16? 32, 64. That's 4, 40, 20. Okay, let's try this. A little bit too much. 7, 15. Okay, move it up a little bit. I mean, we could also scale it up, because then we have to redo those. But I guess we can have other things in there. So what we could do, one thing that I want to do is I want to show the next tetromino. So let's do next tetromino. So you can kind of plan, you know, what you're gonna do. So the next tetromino, we start out with a new one, and restart should also set it to something. Okay, and then I want to draw this as well, but before that, when we make a new tetronimo, actually, yeah, because then when we're doing this, we're getting a new one. Actually, we don't. The next one should be new, but the active one should be equal to the one that is next. So we're basically copying over that. Okay. Yes. So, and now we want to draw it as well. So we draw the next tetronimo. We want to draw at, let's do, I'm gonna go with to the left side. So let's do like minus. I guess 7. So that should draw that tetronym. Oh, that was too much. Wait, it could just be at 0. Actually, it probably needs to be added because, yeah, because we have left padding. That's a left padding minus 7. Okay, it's not that big of a deal, but let's just, actually it needs to be a little bit more. Actually, let's do 6. Okay, so now we see the next one up there. Cool. We can also add a little label to it if we want. We can add a little border around it, I guess. Border, grid. Actually, we could just do like grid parse. Sorry, immutable parse. And gonna be like 1, 2, 3, 4, 5, 6, maybe 6 width, so we get 4. I think 4 is the maximum size. I'll just make this square here. 5, yeah. Okay. And then we have the color is just gonna say light gray there. So that is the border. We can draw this border at the same next position. But I probably want to add one here, so let's move it back 1. And 1 there, and then this will be, no, wait, let's keep that, and you're, hang on, let's do that, and then you're gonna, I'm gonna add 1 here. Okay. So you get drawn in the center there. Why is it not? Oh, it's only 3, so 4. There we go. Wait, but now it's 6 high. 4. Well, now it's 4 by 4. Oh yeah, it's 6 by 6 now. Okay. Okay. Okay, let me add 1 more. And we'll add 2 here. So it's like it has a little bit of space, a little bit of padding. Cool. Okay. Now I can see the next thing there. Now I want to add maybe score. So actually, yeah, let's do like gameplay stuff first. I might add like sound effects, because I do have a program which makes it pretty easy to make a little blips and blops sound effects. But let's make a score first. So I'm gonna say this is the current score. It's gonna be some kind of U size, I think. Start at 0. Now, how much score? So how much score would you get for different lines? I guess, like, how would they okay, let's do calculate line score and number of lines. So I guess what we could just do is we could just have an because either you score 1, I'm gonna say 100, you score 2, 250, 3, 4, that doubled. This more than doubled. How much is this? This is like 150%. It's not gonna work now. Wait, 4 is Tetris. So that should be like 1,000 or something. Okay. I don't know. Maybe it should be more. Maybe it should be like 1, 2, 300 and then 1,000. Or 2,000. Let's make it 2,000. Yeah, let's keep it like this. Okay. There could be other ways to score as well, but let's do it like this. So now let's draw the score somewhere. So we have like draw text, and now we can we get to the formatting here, because we can say score is equal to some score here, and the score is going to be well, self.score. Position is something. Let's do, where would this be? I don't know. We'll have to kind of figure this out, but I'm gonna do, actually let's put it above maybe, or to the right, or to the left. I don't know. Let's put it to the left. Font size is, I don't know, 20 maybe. See how this looks. All right, we got a little score there. Let's move it a little bit. Okay, that's fine. Well, maybe that's too little space actually. You know what? Let's just do score, and then the line below is going to be the actual score. So we have more space there. Cool. So that's the score, but we can't get any score yet. So we have to, that's going to happen over here. Handle line clears. Right, so we have to count how many lines we cleared. Cleared lines is 0. If we cleared a line here, we should increase this by 1. And then we add score based on cleared lines. Calculate score, cleared lines. Oops. Must handle all. Right. So since we can't get any higher or lower, well, I guess technically we could maybe get 0, but I think we just say 0. Com time only. Oh, return. There we go. That's a weird error to get because we didn't return. But okay. There we go. See if we can get some lines here. Okay, I think next thing I want to do is the drop. There we go. 100 score. So now we have score. See if we can get a double. Yay! Okay, cool. Now let's do the drop. I think it's gonna be pretty simple actually. The drop is gonna be space, I think. Drop. So essentially it's gonna be kind of the same thing as fall step, except in a loop. And we check collision each time. And once we... So this is drop. I'll remove the comments for now. So while, I'm just gonna do while true for now. If we don't find a collision, we continue. If we did find a collision, we are actually down here. And we do this, which now shares with the other function, full step. So I think what we'll do is, I think we'll say, I guess, commit tetromino or something. I don't know what to call this. And it's gonna do all this. We are going to commit that. And then let's do that. And over here, we're going to commit that. Okay. I'll move down into a declaration up here so we can use it everywhere. All right. So now we should be able to drop, I think, with space or crash. I think it crashed. Yep. Wait. Okay, I'm not sure what happened, but... Oh. Okay, while true. We never actually broke out of this while, so we should break over here. Or return, whatever floats your boat. There we go. We can also do return commit to tetromino. No. There we go. Oops. Oops. Oh. Oh man. Yeah, it goes pretty fast. Okay, that's another thing. Maybe now is the time to do what's it called? The difficulty. Yeah. So we'll have a level starts at 1. Restart should... Oh yeah, restart should restart score as well. And level goes back to 1. Okay, and then we draw the level. Maybe we should draw level above score, maybe, I don't know. Level could probably be over here. Let's do this, or maybe one more. Okay, level 1, yeah, cool. And let's say that this is like, I'm gonna call this the initial false step duration at 1 second. And we'll add full step duration is a function returning f64, and we'll return so this is going to be some kind of algorithm here, float from int. So I'm gonna do f level for float is an f64. It's going to be float from int self level, and essentially that's just going to determine the speed. So I think maybe every 5 or 10 levels or something like that is going to increase the speed or something like that. I don't know. Or should it increase the speed every time? I don't know what really level means actually. I think in some games it's like changes the color and stuff of the Tetris, like it changes the palette. We could have that as well, like have different palettes. That's going overkill. I'm just gonna do a simple, so it's the level times the initial step duration, except it shouldn't be times, it should be like divided instead, because it should go faster, but actually we could do this. Let's do, so we have the initial full step duration, we have like max level. Max level should be like the max level where the speed stops increasing, essentially. So max level speed or something. I'm just gonna call it max level, whatever. Let's do like, I don't know, 20. So it goes from 1 to 20, and then you reach max speed. Max full step duration then is going to be, so here we just do like, I don't know, 1.1, 0.1. That's going to be pretty fast, pretty darn fast. Okay, initial full speed step duration. So this is going to be, you can do a lerp from, so we need a ratio. It's going to be max level. If max level is max level, and so it's going to be from, so the ratio is going to be level over max level. That's how far you've gone, basically. If this is 1, it's going to be like 1/20th of the max speed. And so the speed will be, or the duration, the relative duration is going to be max duration minus initial duration. No, other way around. Oops. But it's going to be an F64 and it's going to be float from int. Okay, and I will lerp from No, actually we don't do this. We do initial. Well, we need like f of all these. F initial duration is going to be float from int initial duration, and then max duration. Let's just call it dir. Yeah, max. As you're going to go from initial dir to max dir, with ratio being the thing. Except, is this actually the ratio? I think it should be like 1 minus this, because we need to invert it. No, we don't actually. I don't know. We'll try this. So that's the actual full step duration that we have to worry about. So next full step at needs to be full step duration. Move it down so we get the correct level. There we go. Or not. You are already F64. Oh, right. These were already F64. Okay. Good. And you are a function. There we go. Okay, where are we now? Okay, so we have this. Okay, but we don't have any way to increase the level. So I'm thinking each 10 lines will increase the level, maybe. So, oh, also we should probably keep track of the lines. I think that's the usual metric that you have in these games. So let's actually put lines somewhere here. Lines. Yeah, sure. Let's have that over there for 16. All right, we got lines. We need to increase them though. So handle line clears and self lines plus equal cleared lines. Now the score could probably also vary with the levels, but you know, that's up to how you wanna define it. I'm just gonna test if this works here if I can actually play this game. Also, some games have like an indicator at the bottom to show where you would drop, which is kind of nice sometimes, because sometimes it's pretty hard to line the piece up with whatever you're doing. Can I actually rotate it? No, I can't. Okay, so you can't do some fancy moves where you rotate, you know, forcing a rotate into something else, but whatever. That's fine. Okay, so the lines actually go up. And so I want, when we clear 10 lines, now let's see. So actually, we could just set level equals to lines mod, no, not mod, over 10. So div floor over 10, right? So now every time we clear a line, it's gonna update the actual level. Oh, except it needs to be +1 as well, because we start at 1 and not at 0. Okay, let's try to get to level. You know what? One thing before we do that, I want to just add some sound effects. I'm not sure if you hear this very well, but this could be the move blip. Tetris move. Okay, let's do another one. Actually, this one is actually good. Okay, this is a little longer. This is like, I want this to be when you take it to the bottom. Okay. I feel like it should have a little bit more oomph. You can add things like, yeah, vibrato. I don't know. Sure. Let's go with that. Tetris land. Okay, and now we have like, let's do when you clear a line. I feel like we should have like a repeat here. Okay. Now. Okay, let's do that. Tetris clear. Okay, so we have Tetris, we have like clear. I'm just gonna copy this. No. Tetris over to, I guess, here. Now we have a bunch of Tetris stuff. Wait, why are they not? Should be wave files. Oh my god. Move wave. There we go. Okay, cool. Now, in order to get these things in the game, I'm going to first add a bunch of sounds here. So we'll have let's make a little jukebox or a sound box. I don't know. I just made this up here. So this will have all the different sounds. So we'll have because now it's like namespaced to sound, so we don't have to say sound underscore whatever. A Tetris. This is like we have land, which is a sound. We have move. We have, I guess we could have one for game over as well. But yeah, we have move and we have clear. All right. And let's play a sound. And what you could do is you could do like field enum of soundbox, which gives you the actual, which, yeah, I can show you here. So this plays the sound, play sound, and also we need self. And it's going to be like field, this is comp time, sound, this is going to be field of self with sound, except you need to be tag name. Okay, so a little bit of magic going on there, but let's see. So essentially we're taking one of these enums and as a so what this means is that we can now provide an enum value here instead of a string or something like that, or just the sound itself. But the problem is that LSP doesn't actually understand what it's evaluating to, so we don't get auto-completion, but we do get compiler errors if we don't provide one of these sounds. But now let's add this soundbox here, and we're gonna well, let's just actually load these as well. I think what we can do is we can automate this loading actually. So let's do init. I believe this could be an error, but we're just gonna ignore those. So this returns the soundbox, but we will make, yeah, so let's make a soundbox first. And let's set it to undefined. And we'll return this later. And now we do an inline for fields of the soundbox for this. And yes, no, there's no difference. And then we get a field. So now we get the field. So the field, we should say then soundbox. Well, we get the sound first. So the sound is going to be load sound. And we need a file name. So let's pass. We're gonna have to get a file name here. So we get a buffer. It doesn't need to be this big, but whatever. And file name is gonna be path join. Oh wait, this doesn't work. What is this format join? As if you have like a formatter. Oh, okay. Oh, that's pretty cool. Okay, so I'm not gonna explain any of that, but you can use this with format buff print. Actually, I think we need Z, yeah, because this is 0 sentinel. So buff print Z because it's raylib, and we're gonna print out. So this is, we have the buffer, the format is gonna be F, and then the value that we pass in is gonna be this thing over here. So we format join a bunch of paths. So these paths are gonna be, wait, I don't even know if we need to do this actually, because it's gonna be in the relative path. Yeah, it's not path. It's not path we need. We need, it's but we could, you could do this, but we need, oh, well, okay. The field name, which is either land, move, or clear. So that's one of the names, but then I named it like tetris underscore dot wait, right? So we can make these names like this. I'm just gonna catch unreachable here. Okay. Load sound can be an error. I'm gonna catch unreachable there as well. It's just gonna panic exit if something goes wrong here, which hopefully is does not, unless I mistyped. It's clear, land, and move. Yes. And the sound is unused. Yes. So now we say that the field of soundbox whose name is field.name should be equal to the sound that we loaded. And now we type .init. So that should now load in all the sounds there. If we start this up, nothing's gonna happen yet, but we should see at the logs, unless we get this error here. Well, we got a runtime error. Oh, I see. Right, I forgot something. So if you want to use the sound with raylib, you have to do init audio something. Also, I think, I'm not sure if this is needed, but you can do like defer close window, close audio device. Yeah, it's probably good to do this here. Okay, let's try this again. Oh, we got another issue, maybe. Attempt to unwrap error load sound. Failed to get frame count. Data loaded successfully. So it loaded the file. Then we got a bunch of warnings. And there was an error with load sound. Okay. I mean, which one was it? Land. Okay, I mean, it seemed to have loaded it successfully, but then it failed with something else or something. I don't know. Okay. Is it? Oh, wait. It's because we're creating the game up here. So actually now we need to move this down here because we need to init the audio device before we do this. Right. Yeah. There we go. Okay, so we know that it's loading in the stuff. Now, when are we gonna play these sounds? So, when we move, we should play the sounds. So, let's do soundbox play sound, and then the sound is like move. And the LSP doesn't understand that this should work, but if I remove this to typo this here, we do get this compiler error. So that's great. And then you should also play move sounds. Let's see. Should we also, like, what was, like, fall step should also probably play the move sound. Now we should get a bunch of move sounds. Oh my god, that was kind of annoying, to be honest. Also, it was kind of high volume, so I'm gonna when we load in the sound, I'm also going to lower the volume of these. Volume. Set the sound volume to, I don't know, 0.4 maybe. We can also just set the master volume, I guess. Excuse me. Still pretty high. That's usually what I get, like when you don't adjust. Okay, it's just that it's kind of like an annoying buzz. I'm going to see if I can change this. Maybe reduce the frequency. Yeah, let's do that. Tetris mode. Okay, I'm gonna copy. Let's copy only move to Tetris move wave. Okay, and then when we land, it's probably pretty. I'm not sure if playing it every time is good, but whatever. We have some sound now at least. So let's also play a sound when we land. So I guess we could play it here. Soundbox play sound, and it's gonna be land. Okay. And also here is like if we have any lines cleared, which we don't necessarily have actually. If cleared lines is 0, return. Okay, but then here we play clear. Okay, I want to change the sound of the landing because that sounds weird. Let's remove this. Now, what's making it? It's the vibrato, I think. Oh. Yeah, let's do that one. Tetris land. Maybe we should have one for when we... I feel like this is when you get a new level instead of clear. I think, yeah. I think this should be Tetris level. And then clear is something else. So... No, that's not it. How is it doing that, actually? That's weird. What is making it like go like that? I'm not sure how loud you can hear this sound here. Okay. Okay, I'm just messing around now. I don't know. I don't know what sound it should be. And that sounds more like a upgrade or something. Hmm. Sure, let's do that. I don't know. Okay, let's see. Copy Tetris land. Tetris clear. And level. Okay. So we add a new sound here for level. And there we go. Now we have the level. We don't need to add any other things. We just add this enum, or I mean not enum, but this field here. And it's gonna be loaded in automatically here. Oh my god, have you ever seen such stuff and shit? Okay, let's see. So this lands and the line clears will play the clear sound. Pre-level. I'm gonna do this then. So we're gonna say like, okay, what's the previous level? If the level is more than the previous level, we will play the level sound. Otherwise, we will play the clear sound. So there we go. Now we have land, we have level clear. So yeah, that should be good. Okay, I'm thinking of removing the move sound only for when it's naturally falling, maybe. Okay, cool. All right, let's see if we can get a level sound. Whoops. There we go. That actually fits pretty well. Whoops. Oh man. No. Oh no. Wait, can I save this? Oh, shoot. Okay. Well, that's pretty cool. And I mean, I can add like, I don't know, high score maybe. What else could you add to this? Different. Actually, you know what? I'm gonna try and get to level. What is it? Level. Was it level 10? No, actually each level increases the speed, that's right. So I'm gonna see if I can notice that. Yeah, 2000 score. Okay, I should probably show what score you got on the game over screen. Gonna be hard to kind of, you have to remember what you had. Yeah, Tetris. Maybe there should be a combo, like you get a bunch of Tetris in a row that gives you a combo score. No, that's not great. And that sound is maybe a little bit annoying, actually. Oops, I pressed the wrong button. See if I can. Oh, I'm on level 3. It does feel like it's going slightly faster, I think. We're soon at level 4. Yeah, I think it's definitely going a little bit faster. Alright. Oh. No, I double pressed the space. Oh. Oh! Hacks! No! Okay, well, we're gonna get like one of that anyway. God damn it. Okay. Okay. Right. No! Okay, well, it's definitely going faster now. Oh, come on. Oh my god. No. Oh shit. Okay. What? Okay, there's a little bit of bug there, but yeah. I mean, okay. Let's add to the game over screen. Draw game over. We're gonna draw. You scored. Let's add like, I don't know, 80. Let's add. You scored. No. Score. Right. See how it looks. We're gonna get at least a score here. Maybe not. There we go, 100. Oh my god, I skipped it. Okay. It should probably be like a cooldown before you can actually do any inputs. Okay, 250. There we go. You scored 250. Cool. Yeah, so great. I'm not sure what else to add, which could be relevant here. I mean, actually, one thing that I could do is try to make this run in WebAssembly. But that has been a little bit of like a hassle, to be honest. So I probably won't do that now because I have to go now, actually. But yeah, this has been implementing Tetris in Zig using zig+raylib. And yeah, basically only zig+raylib. I think zig+raylib was the only dependency. Yeah. So yeah, and we have like, yeah, we have the board, we have, you know, you can rotate, we have all different pieces, unless I missed someone, I don't think so. And we have some gritty sounds accompanying with us, and yeah, a fully functioning game here. So yeah, that's gonna be it for this time. So thank you very much for watching, and hope I'll see you next time. I'll see you later. Well, have a nice day. Anyways, bye-bye. By the way, maybe we could raid here. We have a couple of people in here. Is anyone having Zig? No. Zig? And do we... Oh. Okay, let's do... Well, I guess let's do this one. Okay, see you later.